Hello there. Let's make sure everything's squared away here. That's good. You, if you wake up, there we go. That seems good. All that good enough. And you also seem good. Excellent. Okay. Let's go ahead. What am I forgetting? Um, this. Terminal ready to go in case we need it. And we will get started here. Just a second. Bum, 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 bum. I want to make sure. Yeah, does need to go. There. All right. We'll have that ready. All right. So, enums and pattern matching. Yep. Enums. I'm just gonna. I'm sure. I'm fine. It'll be all right. Um, values one of a possible set of values. Pretty standard enum stuff. Rectangles one of a set of possible shapes. Yeah. Okay. IP standards. Yeah. Okay. All right, so we got a V4, V6 enum, and we just declare them like that. And we get them like so. And we can say you take a kind just by calling it. All right. Calling it by its name. Or tagging it by its name. What do you want to call that? Okay. So they're saying you might be tempted to do this. Okay. That seems okay. Two instances of struct versus home. Has the value IP address kind is kind. Yeah. Oh, you can put data inside of them. Interesting. Also becomes a function that constructs an instance. Okay. Automatically get it. Store them as for UA. Okay, so you can do. Oh, maybe that's a tuple under the hood. Okay, so they use structs. Yeah, we could make our own if we don't import it. Makes sense, right? Oh, and they don't have to be all the same either. Okay. We're defining different kinds of struct definitions, except that enum doesn't use the struct keyword, and all the variants are grouped together under the message type. Right. Yeah. We could put enums, methods on enums too. Okay. How many chapters are there in this thing? Holy cow. Oh, okay. So there's some projects. Okay. Well, we'll make our way through. We'll keep on keeping on. Okay. Define methods on them. It's just the impl. Motorcycle. Um, okay. Why did we call the method on? Variable M is the value of a message with a string from hello. Self will be in the body of the call when M call runs. Okay. Option typing codes are very common in which value could be something or not, or it could be nothing. Okay, so this is like the nullable that they were talking about. First item in a non-empty list, you would get a value. Okay. If you request the first item in an empty list, you get nothing. Makes sense. Rest doesn't have null. Okay, yeah, I remember this. I've heard of this guy before. Yep, uh-huh. Null is a value is currently invalid or absent for some reason, right? That makes sense. That's how I think of null too, usually. Okay, so option is an enum. In the prelude, variants are in the prelude, some and none directly without the option prefix. Generic type parameter. Yep, pretty normal. Some variant of the option enum can hold one piece of data of any type. Each concrete type gets used in place of T. Okay. Okay. That makes sense. First is to annotate the overall option type. Either can't infer the type that the corresponding sum variant will hold by looking only at a none value. Right. Oh, okay. So okay, you can't just right. Okay. Absent number to be it's an option I32 and it's a none right now because it's absent. But you have to tell the option that it's supposed to be. I see what they're saying. Rather won't let us use an option T value as if it was definitely valid value. Okay. So I mean it's kind of like just a nullable in Dart even, right? Where it makes you check to make sure that it's not null before you go use it. It doesn't the compiler doesn't do it, but you get IDE hinting for it. IDE hinting for it. And it'll panic and they're trying to avoid that, but like very similar, right? Same vein, same kind of approach. Oh, you know what I forgot? I know what I forgot to do. Make sure that's running. All right, and if we run this because we haven't checked in any way, shape, or form, and this is an option. No implementation for an integer 8 plus an option integer 8. Cannot add option to yeah. I mean, yeah, this is the same thing. I mean, this just feels like normal, dealing with the type system to help you out, right? Option T to a D before you can perform D operations. Okay. Okay, but like, how do you do that? right here. I mean, I don't want to go read this, really. I want you to tell me. You're the book. Preferably with code snippets. Assert equal is some and is none. Is none or. Okay. I'm gonna not worry about that just yet. You'll have code that will handle each variant. You want some code, you'll run only when you have a sum t value. This code is allowed to use the inner t. Some other code to run only if you have a none value. Doesn't have a t value available. The match expression is control flow. Okay, yeah. Okay. So match is the answer. And then they're going to talk about it. Patterns can be made up of literal values, variable names, wildcards, and many other things. Okay. Chapter 19. All right. Yeah, okay. I mean, it functions like a switch, but with more things, is what I'm getting so far from what they have said. Okay, so we have value and cents, takes a coin, returns a U8. So we match. Are you a penny? You're a one. Yada, yada, yada. Okay, cool. Makes sense. Yeah, all right. Okay. And we saw that over here, actually, where we can put multiple things in instead of just the arrow. Or no, actually, it was right here. Yeah. Bind to the parts of the values that match the pattern. Okay. Add this information to our email by changing the quarter variant to include a US state value stored inside it. We should be done. Okay. So we've got an enum there, and then a quarter contains that. All right. We had a variable called state. Okay. To the pattern that matches values of the variant coin quarter. When the coin quarter matches, the state variable will bind to the value of that quarter state. Then we can use state in the code of that arm. Like so. Okay, but what if there's no state specified? How do you correctly handle that case? Value and cents, coin quarter, Alaska. Okay. Yep. Uh-huh. Okay. Yep. Uh Also option T using match. Option I through two. If there's a value, okay, so why didn't they just use their earlier example to expand upon it? There's value inside adds one to that value, and if there isn't one inside, function should return the none value and not attempt to perform any operations. Okay, so we have our deal. So it takes an option. So you do an option for state. And in fact, let's do it. Let's actually do this. If we can. Do we have enough? Do we have enough knowledge? I think we do. Well, we need to know how to match inside of here, I suppose. Look like listing 6-5, which is you. Oh, no, yeah, okay, so... Well, no, that's not what we need. So there's second listing, there's none. Okay, yeah. Matches, there's no value to add to. So program stops, returns the none value on the right side of the arrow because the first time match. No other arms are compared. So we just, yeah, I think we can do this. I think we have what we need right here. And it'll be good to kind of stretch the brain out, right? Okay, so we can do this. We can open this new Tricha. If you would catch up, refresh. Hello. Yeah, you're there. There it is. Geez, it took forever. This window. Okay, so we can start from here, right? We can do our derived debug. Why not? If we can spell correctly. US state. And we have like Alabama, Alaska. We'll just use those two is plenty fine. And we'll have an enum coin like they do, right? There's a penny, nickel, dime, quarter, option, US state, right? In theory. Let's go. Now we'll empty out our function. We can do this like they did, like so. That's all well and good. What are you complaining about? Just I don't return yet? Yeah, that's why. We can match on coin, right? We can do exactly like they did. And then here, can I just call it state? Yeah, option US state. And then in here, I can do this. So exactly like they did down here, match on state. Oh, we also need to, no, we just print it. Okay, yeah. So match state none. We can print line no state provided. And then sum, call you S. And then you can do multiple things in here. Notably, you can print. Oh, theirs returns an option as well. No, we're okay though. I don't know if I have to return here as well. We'll find out. This is probably bad Rust code, but it just literally doesn't matter. We're exploring and learning, right? And we'll use their example here, and this has significance, and I forget what it is exactly now. But this is actually just S. Is it because I'm missing that? No. It's probably because I don't return yet. And am I allowed? I can't do that. I can do this though. Except, why are you in my way? Get out of my way. There's probably a nicer way to do this, but we don't have the knowledge just yet. Keyword can be lifted out of match. Oh, return keyword. No. I don't want to. I like that. Okay, so then if we were to call let US coin, it's a coin, it's a quarter. And we can use Alaska. I thought I could do yeah, see here's the exact problem here is that they haven't shown this code. They just snipped out like all of the stuff around it. And now you can't look at this and see what you've done wrong. Like, what have I done that's stupid here? Oh, US coin should be snake case. Okay. Sure. You can be a snake case if you want. Because they just told us that we can do stuff like this. But they didn't cover. You didn't cover this. Like, is this the only syntax? I guess is just my question. Like, is this the way it has to be, just for my own knowledge, right? Why do you think it's never used when I'm using it right here as well? Um, for you US quarter, quarter, like so. Do I have to specify, even though it's an option? I need to do equals none. But I can't. Is this the syntax I would use? Yeah, it is. Okay. I guess. And then let's do, just for fun, and we can print line value in cents, quarter, I would need to do in braces with that. No. Oh, I need to put you in a string. That's what I'm messing up here. Oh, that, you know what, they've talked about this. You can't call it in there. I need to do it here. Done. There we go. And we could actually put that all on one. Nah, let's not. It'll be nicer output to read if we just do them like this. Order. And then US quarter. Right? So this should be able to run and give us 10 no state, 25 state. Oh, because we print out before we return, yeah. So 10 and then no state provided, and then 25 state quarter from Alaska. We could also do, we could omit the printing and just do a returning. Oh, comma. So 10, 25, state quarter from Alaska, 25. And if we were to flip this, it'll be just a little bit easier to read the output just as an accident of how it be. So 25, 10, state quarter from Alaska, 25. And then, yeah, okay, Alabama's never used. That's fine. Nor is penny and nickel. In the interests of just making this output clean, for an example, AK quarter, and we can have AL rather, Alabama. I don't know why I thought Georgia for a second there. Quarter, dime, nickel, penny, like so. And your AL quarter. I think AL's Alabama. And we get a nice clean output. We get all of our little deals. We got a state quarter. We got a state quarter. We got a regular quarter. Life is good. We did a thing. Status. We're good there. An example of option or matching options inside of you know, that can go. I'm happy with that as just a thing that we could talk about and look at in the future. Okay, where were we? We were in matching down here. Match on none or some, cool. X is none. We into the magic come in first arms, none. Okay. They're exhaustive, must cover all possibilities. None not covered. Okay, cool. It can also take special actions for a few particular values. All other values take one default action. Okay. Oh, so just other is the equivalent to default. All right, cool. Okay. Yep. Let's see here. You can also just underscore to throw it away. Yeah. Chuck it out the window. If you're under 3 or 7, you must roll again. We no longer need to use the catch-all value, so we can change our code to use underscore instead of the variable name other. So whatever else happens, just do it. Okay. We can also use the unit value as the code that goes with it. Okay. Like, I wish I could see, like, is this in main, or does this have a return? Like, what are the implications of this in a function, right? Because you got to return a specific type. What this? Or does it not come up, right? If let and let else, okay. If let. Programming listing 6 it matches on option U8 value. Big max. Variable only wants to execute coded values. It is the sum variant. Like config max is sum that. Match on config max. Sum max. Print line. Max was configured to be that. Otherwise, nothing. Value is sum. We print out the value in the sum variant by binding to the value to the variable max in the pattern. We don't want to do anything with the non-value. Satisfy the match expression we have to add. Okay, whatever, it's fine. Which is annoying boilerplate code to add. Yeah, I'm not that bothered by it. Shorter way of using if let. Sum max is config max. Then we can print. I just don't really care. Like either is fine, I guess. From what I can tell. Takes a pattern and expression separated by an equal sign. Works the same way as a match. The expression is given to the match and the pattern is its first arm. Okay. Pattern is sum max. And the max binds the value inside sum. Yeah. Choosing between match and if let depends on what you're doing in your particular situation. Whether gaining conciseness is an appropriate trade-off for losing exhaust checking. Okay. Can include an else with an if let. Yeah. Oh, okay. So there's the more concise. Except let's try this actually. So here we could actually do if let well, this is an option. Hang on. So it'd be state, right? US state. Like this? No. It'd be state equals S. Other way around. If we have state, then we print line this guy again. And then here we can just return our 25 in both cases. Okay, this doesn't like this. Irrefutable if let pattern. If let with a let. So oh, I've done this wrong, basically. I would need to instead do this is a stum. What would be the correct way? Um Going quarter state, yeah, but this is a little different. So this. But it didn't like that. Would it just be some? Because it would be okay. Or no. It'd be this way. There we go. And then I guess we could do that. No. We still need to do S because we assigned state to S is what we did. I've been awoken. How's it going? That's going all right. We're just I was just playing around with this. And then this should still all work. I knew Clippy would keep you good company. Now me and Clippy are already fighting because it's mad about my return. I don't know if this is Clippy or just JetBrains thing, but it doesn't like it, and I don't care. It's gonna live with it. I do want to jot down for me below block are equivalents. Well, not really. They're a little different. I guess it'd just be is a more cautious way to approach this. Because that's not even true, really, is it? Because you're not really gaining anything by doing it this way other than I mean it's laid out nicely, it's fine. You're just eliminating a dual return that's a little bit wonky. We're really only just doing this if we get a value in there. Hopefully future me will remember what I was talking about. Hang on 1 sec. It is humid today. Mouse return early with let sum equal mouse return. Well, I want to return 25 in both cases, right? That's this thing prints out the value and cents of your thing in just a nice little list. And yeah, I know I could combine them, but I just didn't. Just want to keep it simple if I want to refer in the future and get a quick memory jog. Okay, so Flat, else we can do that. Okay. Some patterns perform some computation when a value is present, return default value. Otherwise, continuing with our example of coins with the US state value. If you want to say something funny, depending on how old the state on the quarter was, I'd introduce a method on US state to check the age of a state. Okay. US state existed in. Okay. Might use a if let to match type of coin, introducing a state variable within the body of the condition. But what about your other? Oh, describe state quarter. I see. You're putting it into a different function. Question produce a value either to produce the state from the if flat or turn early. So if it's a coin quarter state, it's coin. We have state. Otherwise, return none. I don't understand what this is doing here. Reduce the value either to reduce the state from if flat or to return early. Oh, because you're wrapping it, I see. So state is either this or none. See, this is exactly the lack of fucking control flow statements that I don't like. Like, it's hard to understand what this is doing at first. This effectively becomes almost like an anonymous function here. Okay. This is a bit annoying to follow in its own way. Yeah, no fucking shit. Make this common pattern nicer to express. Rust has let else. Okay. Let else syntax takes a pattern on the left side and expression on the right, very similar to if let. Does not have an if branch, only an else branch. Pattern matches, it will bind the value from the pattern to the outer scope. Pattern does not match, the program will flow into the else arm. Okay. Now see how listing 6.8 looks when using let else in place of if let. So we let it equal coin quarter state is equal to coin, otherwise return none. We bind state, and then we do these things on it. Return is often explicit use to return early. When you see it's returning out of the function, now return means it's being assigned. Yeah, I don't like this. I don't like it at all. Okay, so that. Notice it stays on the happy path in the main body of the function this way without having significantly different control flow or for two branches the way if let did. You have a situation in which your program has logic that is too verbose to express using a match. Remember that if let and let else are in your Rust toolbox as well. All right. It's beautiful. No, it's not. Like type fucking return. It's 7 characters. It's fine. Do it. I hate it. How many words a minute? I mean, we're almost through chapter 6 already, so we're going good. But that's also because only one Rustacean has arrived to try to tell me that returns shouldn't be on things so far. But it's early on a Sunday. They're all probably still asleep. They were up late dyeing their hair blue. Then write return time every time. Nobody's going to stop you. It's going to annoy me. It's just going to annoy me, and it's going to make this hard to read. Okay, so we have this thing as well. It's a thing. Okay. Yeah, your summary, I don't give a shit. Move on. I'm not even going to read your intros either. It's really not that bad once you get used to it. Oops, ads. Yep. It do be ads. I don't get paid for the extra semicolons in return. Not in this economy. Okay. So, Crate. Crate is a little fella. Modules may be defined. Okay. Binary library. Okay, all the crates you created so far have been binary crates. Makes sense. Libraries don't have a main. They don't compile. Most of the time they mean library crate. And they use crate interchangeably with the general programming concept of library. Okay. Crate root is the source file the Rust compiler starts from. It makes up the root module of your crate. Package is a bundle of one or more crates. Okay. Cargo is actually a package that contains the binary crate for the command line tool. Okay. Cargo package also contains the library crate. Binary crate depends on. Other projects can depend on the cargo library crate to use the same logic that cargo command line tool uses. Makes sense, I guess. As many binary crates as you like. Most only one library crate. Interesting. Why would you do that? Package must contain at least one crate. It's library binary. Okay. Yeah, we already did this a bunch of times. Creates a toml. Source. Toml has no mention of main, right? Yeah. Cargo follows a convention that source main RS is the crate root of a binary crate. Same name as the package. Okay. Likewise, cargo knows as the package directory contains source lib RS. Package contains the library crate, the same name as the package. Okay. How do you know which one it is though? Trigger passes the create root files to the Rust C to build a binary library or binary. Only contains source main RS, meaning only contains binary crate. Package contains source main R. Oh, I missed a different. There we go, right there. Main versus lib. Contains both. It has two crates of binary in the library. Multiple binary crates by placing files in the source bin directory. Each file will be a separate binary crate. Okay. We'll throw you a party if you make it through chapter 10. It's my favorite. We'll see. I have a distinct lack of beverage. Okay. Modules and privacies. Use keyword pub keyword work in the compiler. Okay. Start from the crate root. Just so main or lib, right? Yep. For code to compile. Declaring modules. In the crate root, you can declare new modules. So you declare garden module with mod garden. Okay. Compiler will look for the modules code in these places. Inline within curly brackets. In the file source garden rs. File source garden mod rs. Hello to you as well. Any file other than the crate root, you can declare submodules. Okay. Might declare mod vegetables in the source of garden rs. Look for the submodules code within the directory named for the parent module in these places. Inline source garden vegetables rs vegetables mod rs. Pass the code in modules. Modules part of your crate. You can refer to code in that module from anywhere else in that same crate, as long as the privacy rules allow. Using the path to code, for example, an asparagus type in the garden vegetables module would be found at crate, garden, vegetables, asparagus. Okay. Private versus public. Then a module is private from its parent modules by default. Okay. Make a module public, declare it with pub mod instead of mod. Okay. Items within a public module public as well use pub before their declarations. In a scope, the use keyword creates shortcuts to items reduce the repetition of long paths. In any scope, you can refer to the asparagus crate. Use this. From then on, you'll need to write asparagus. Okay. To make use of it. So it basically just omits everything but the last when you do use. Which we don't have a good example for. Okay. We create a binary named backyard that illustrates these rules. Okay. Crates directory, also named backyard, contains these files and directories. So we got a garden rs. And then it's got a folder with vegetables in it. And in here, we use crate garden vegetables asparagus. It's a public mod garden. Include the code it finds in source garden rs, which is you. They're explaining this in a very confusing way. And then public mod vegetables. Pub mod vegetables means the code in source garden vegetables rs is included too. Okay. That code is just a asparagus struct. Okay. And inline modules are linked in within the files. There's no import in Rust. The modules are the privacy boundaries in Rust. Children can see the parents' private stuff. That's weird. Rust is organized like a tree. Nice thing is everything has a path to it. There's always an absolute path to everything within the project. Okay. I mean that's pretty normal. Like it's weird that this doesn't live in here in my brain. And like this has to be pub from its parents, which is also weird to my brain. Okay. Modules, yes. Modules good in general. More modules in the world. Heckin' modules. Private items are internal implementation details not available for outside. Used to make modules and the items within them public. Okay, I mean that's fine. That makes sense, right? Like ideally, if you draw on your bounds, most of your things in child files really end up being um internal only anyway. The library crate that provides the functionality of a restaurant. Okay. Signature functional either by is empty, blah blah blah. Some parts of a restaurant referred to as front of house and others as back house. Okay. Front of house where customers are. Yeah, no shit, it does all those things. Back of house is where chefs and cooks. It's the kitchen and the dishes. Okay, cool. And managers do administrative work. Maybe. Maybe. This one took me a while to get. You have a file to represent the module itself and a directory for its children. That's represent the module itself and the directory for its children. Um. Oh, you mean this and this? Okay, so we got a module front of house, which contains a module for hosting and some functions, and a module for serving and some functions. Okay. Body of the module then goes inside curly brackets, side modules. Wait, other modules, right? Right. Yeah. Hosting and serving. And also definitions for other items such as structs, enums, constants, traits, organizing listing 7 functions. Right. Group related definitions together. Name them. Name why they're related. But based on groups, right? Having to read through all the definitions. Okay. Source main RS and source librs are called crate roots. Reason for the name is that contents of either of these two files form a module named crate. The root of the crate's module structure known as the module tree, right? So front of house, hosting and serving. Hosting has things, serving has things. Yes, okay. All right. I gotta stand up, stretch my butt, and get a beverage. I've got like the it's too hot in here sleepies, and maybe find another window open. I'll be right back. There we go. I think that's a little better. Maybe. It's kind of letting in more humidity though too. Let me check the weather. It may or may not rain today. It feels just muggy. We'll have to keep an eye on it if it does start to rain. Close some of these to make sure they don't get water in them. No, it's just sunny and hot today. Supposed to be 80% humidity tonight. That'll be fun. It feels like that in here right now, but that's just probably me, my humidity. Let me send this real quick too. All right. So, feel better after I like walked around, except for I stubbed the hell out of my toe on the trash can. Did wake me up, that's for sure. Get the old blood flowing. Okay, so find it in the module tree. Use a path. Yep. Uh-huh. Absolute. Yep. Relative. Okay. Double colons seem to be the name of the game. Ah, there we go. Say we want to call add to waitlist. Same as asking what's the path of the add to waitlist function. Okay. Show 2 ways to call add to wait list from a new function. Or function from a new function. Function junction. What's your function? Defining the crate route. So eat at restaurant, crate route. Crate front of house hosting. Okay. And then this is the librs file. Okay. We'll explain why in a bit. God, that's so frustrating. That's so frustrating. Eat at restaurant functions as part of our library, creates public API. So you mark it with the pub key, right? Closing paths on the pub keyword section. Okay. So we can either do crate, which is presumably the root of this crate, front of house hosting add to wait list, or front of house hosting add to wait list in our lib. Absolute path. Okay. Did you learn a biochecker? Kind of. I learned some things about a biochecker. Pub has a couple of variants too, like pub crate, pub in, pub super, and just pub. Well, hopefully they go through them because so far this is clear as fucking mud. Like, is this all that lives in this intermediary? Oh, it's on the other page. Like, is this all that lives in the file that lives at next to source or to main? Or what? Like, first time we call add to wait list function eat at restaurant. We use an absolute path. Okay, yeah. Which means we can use the crate keyword to start an absolute path. Then include each of the successive modules until we make a way to add a wait list. You can imagine a file system. Like, yeah, it is a file system. We'd specify the path, but yeah. The second time we call it, we use a relative path. Yep. Tree starts with front of house. The name of the module defined at the same level of the module tree as eat at restaurant. Here the file system. Okay, yeah, I understand file systems, dude. And I mean, technically, these are both relative paths if you're saying that crate is your root directory of the crate. Like, I think this is the weakest part of the Rust book. It's one of those parts you just need to learn when you use it. Yeah, I mean, like, Go's module explanation documentation sucks ass too. Like, it's so hard to understand at first. Like, you learn more from like looking at the standard library organization. I think it's suddenly, like, you read all the shit in their docs, you're like, what? And you look at the standard module organization, you're like, okay, this makes perfect sense. But like, also, like, I am the guy that wants to understand the correct way to lay out a project, because there's reasons for that way, and I try to follow in general the best practices of a language in general, unless I just flat out disagree with Go. Also, doesn't like empty returns, and I say to hell with you, leave my empty return in there, it's a very clear signifier of what's happening. You are the verbose language. Shut up and let me be verbose. Okay. Idiomatic, yes. You're idiomatic. All right. Item definition code separately from target with the code that uses that item. Okay, yeah, whatever. You ever use Emacs? No. Error messages say module hosting is private. Okay. Because we didn't pub it up. Hosting is defined here in lib. Hosting is private here. Hosting is defined here. Why did you do that twice? Oh, because we called it twice. Duh. That's why. Error message say, yep, private. Correct password hosting. Well, yeah. All items are private and parent modules by default. You may want to make an item like a function or struct private. You put it in module. Okay. Can't use the private items inside child modules. Items in child modules can use the items in their. Yeah, this part is weird. That's really weird. Child modules wrap and hide their implementation details, but child modules can see the context in which they're defined. Continue with our metaphor. Think of the privacy rules as being like the back office at a restaurant. What goes on in there is private to the restaurant customers, but office managers can see and do everything in the restaurant they operate. No, they can't. That's why they have cooks. Unless they happen to have been a cook, in which case then maybe. Hiding inner implementation details is a default. You know which parts of the inner code you can change without breaking the outer code. It does give you the option to expose the inner parts of the child module's code to outer ancestor modules by using the pub keyword. Yeah. Makes sense. So yeah, if we do yeah, the error we already talked about. Pub keyword in front of mod hosting makes the module public. This change we can access front of house. We can access host string, contents of hosting, or we can access hosting, but the contents of hosting are still private, right? Making the module public doesn't make its contents public. Makes sense. Pub keyword on a module only lets code in its answers to modules refer to it. Not access in code. Modules are containers. There's not much we can do but making the module public. Yeah. Uh-huh. Right, the waitlist public also becomes public. Makes sense. Better analogy would be a waterfall. Everything in main can be accessed by everything in the crate. Yeah, that's still super weird. Like I understand what they're saying. It's just weird. Why do we care about the paths for like I don't get what they're saying. Hang on. Front of house module is defined in the crate root, while the front of house isn't public because the eat at restaurant function is defined the same modules front of house. We start with crate. The root of our crate's module tree. Front of house module is defined in the crate root, right? Okay. Well, front of house isn't public because the eat at restaurant function is defined in the same modules front of house. But is eat at restaurant and front of house are siblings? We can refer to front of house from eat at restaurant. This is the hosting module marked with front of house isn't public because eat at restaurant and front of house are in the same module. They're siblings. We can refer to front of house from eat at restaurant. Can you refer to the package but not access things? Can you access things? Hosting module marked with pub. We can access the parent module of hosting so we can access hosting. Module marked with pub. We can access the parent module of hosting. And the waitlist function is marked with pub. We can access this parent module as this function call works. Okay, I don't understand anything that they're trying to make a point of there is lost upon me. And then this. Yeah, I don't get whatever. Package can contain both a source main RS binary crate root as well as a source lib RS library crate root. Have the package name by default. Packages with this pattern are containing both a library and a binary crate will have just enough code in the binary crate to start an executable that calls code to find a library. Okay, that makes sense. Like you've made a library, and this is like a it interfaces with that library to do the thing. Other projects benefit from the most functionality that the package provides because the libraries create code commission. Yeah. Module tree should be defined in source librs. Any public items can be used in the binary crate by starting past with the name of the package. Binary crate becomes a user of the library crate. Right. Yep. This helps you design a good API. Yep. Demonstrate this organizational practice, the command line program that will contain both. Okay, cool. We'll get there and we'll do a thing. Relative path was super. Super. Thanks for asking. Begin the parent node rather than the current module or the crate by using super at the start of the path. Okay, so it's ... It's like starting a file system path with dot. Yeah, literally same page. Thuber allows us to reference an item that we know is in the parent module. We can make rearranging the modules tree, which can make rearranging the modules tree easier when the module is closely related to the parent, but the parent might be moved elsewhere in the module tree someday. Okay. So it seems like using Thuber is probably the best idea. If you like to refactor and move things in the future, just do it like to start, because you always like to refactor and change things in the future. Let's see here. Consider the code. We shall ponder the code as though it were an orb. Models a situation in which a chef fixes an incorrect order. Okay. Personally brings out to the customer. Function fix incorrect order defined in the back of house module causes function deliver. Cook order. Super deliver order. Okay. Specifying the path to deliver order starting with super. Fix incorrect function. Incorrect order function is in the back of house. Here, module. So we can use super to go to the parent module of back of house, which is me. Oh, which is the crate root. Oh, because we're in lib. Yes, you mentally have to think about what context things live in. If you use a framework, you put that in the root and you don't have to re-import all the core definitions over and over. Yeah. Super! You like that? In each case is the crate root because we're in librs here. Yeah, okay, I see. From there, we look for deliver order and find it. Right, yeah. Success, we think the backup house module and the deliver order function are likely to stay in the same relationship to each other and get moved together. Should we decide to reorganize the crafts module crates module tree, therefore we use super so that we'll have fewer places to update the code. Yeah, if this code gets moved to a different module. Bump, 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 bump. Structs and enums, you pub them, right? Yep. Few extra details. We use it before a struct definition. We make the struct public. Yep. Structs fields will still be private. And you must do that as you see fit. Okay. Makes sense. Public breakfast struct the public toast field, but a private seasonal fruits field. Okay. Like none of this makes any sense to the code, but okay, whatever. Somebody was hungry when they wrote this, is what I'm taking away. Or like hyper fixated on the restaurant industry for whatever reason. They were watching Kitchen Nightmares, weren't they? Weren't they? Oh, hang on. Hang on. No. No. Anyway. You. Because the toast field is public and eat at restaurant, we can write and read to the toast field using dot notation. Okay, yep. Okay. Right. Because back of house breakfast has a private field. The struct needs to provide a public associated function that constructs an instance of breakfast. Okay. So we impl, we say summer. Give me the summer breakfast. And it's peaches. Breakfast didn't have such a function. We couldn't create an instance of breakfast. Okay. Because we couldn't set, yeah, makes sense. Make an enum public, all of its variants are then public. Okay, that makes sense too, right? It's fucking roll. It's exactly what I was thinking about. And I was thinking, like, do I want to like figure out, do I want to add to my to-do list like a bits or something, or not bits, but channel points reward to play a GIF? Like, is that a thing I could do? And then I thought about it for a second. I was like, no, I don't really want to like, I don't want my stream to be making a lot of weird noises for people that like to co-work along. Like if they want to just chill out, veg along, play some tunes, like I don't want to be a messy, noisy fucking morning radio DJ playing stupid noises constantly sort of thing. But maybe it's something I could investigate for gaming streams, because those are more noisy anyway. Although somebody was at work watching me play last night. Do I get a plushie for all the YouTube chat points I got? I don't, there's no fun interactions for chat on YouTube, right? A Mongoose plushie, right? Like when I'm rich and famous, I'm down to make plushies. Absolutely. Make me rich and famous. Tell all your friends to come hang out. Tell them to share my videos and clip them and send them places and do all of that stuff that everybody does to the big names. But like there's no YouTube points, right? There's just like top fans thing. You get XP, I guess, but I don't think it carries over, does it? I don't really follow people that do YouTube live. I'll let all one of them know. Okay. That reminds me, I gotta like, I played way longer than I thought I was gonna play last night, but Dune is super fun. Super fun. I was really pleasantly surprised. Like I don't generally hold Funcom in high regard as a game developer because of how Conan released. Like it released in a broken and just fundamentally like confusing state. Like it seemed like they didn't actually want to make that kind of game. And they didn't know what that kind of game was supposed to be, right? Like they didn't subvert expectations in an interesting way. They did them in a way that reflected just a lack of awareness. And they eventually patched it to be way better, right? But dude, Dune was hecka fun. You could definitely tell there's like some common there's a common lineage. You could tell it came from the same studio in a lot of ways, but it's a much better execution. But I should go through that stream and pull out clips and promote that. That's what I should do. Because game content, there's a little bit more like stuff going on that you can pull out. And then maybe I'll find some other nerds. And they can come hang out here too. All right. So, yeah, we can't mess with our toast. Or our fruit, rather. That's what they're saying here. Don't touch the fruit. You can do whatever you want to the toast, but don't touch my fruit. And then enums, yeah, enums don't need a pub on each thing. Enums aren't very useful unless their variants are public, right? Yeah. Be annoying to have to annotate all enum variants. So this is the first time they've said something would be annoying where I'm like, yeah, that would be really annoying. Structure often useful without their fields being public. Yeah. Yeah. Zig devs can only dream of privacy. That is one of the things that rubbed me the wrong way about Zig when I started like reading about it a little bit. Like everything is public always forever just seems so weird and backwards to me. And like Python is that way too, right? But in Python, well, I haven't written Python in many years. They may have changed this. Like the last time I wrote Python, they had just finally decided that type annotations for arguments would be a good idea. Thank you, right? But it used to be you could underscore, and by convention that meant underscore the start of a function name. And by convention that meant you shouldn't be in here messing with it, and your IDE should complain at you, right? That didn't stop people, old people that I worked with, from saying, well, I'm just going to call this anyway, and doing it wrong and breaking stuff. Whether or not it was broken initially or if somebody changed the thing that they thought was internal only and was safe to change is completely and totally irrelevant in the sense of like assigning fault. It is completely and totally the exact point of why it should have been private and not messed with. Because that signifies things about that code that you can reason about, right? So to say everything is just public by default is just way crazy to my brain. Like often when somebody that writes a language like Odin, right? Gingerbill is famously anti package managers. He hates them. He thinks they're the worst idea ever. He refuses to make them or whatever, right? And I may be summarizing somewhat incorrectly there, but that's just like the vibe. Like I can understand where he comes from with that, right? I like package managers. I think it's good. I think you need to be careful. You need to be disciplined. You need to not import fucking left pad. But I can understand his sense, like where his mindset comes from with that, right? It makes sense to a degree. I don't necessarily agree. I understand. Public by default, I don't understand. And it doesn't make sense. All right. And they may have changed something. It's been like 4 years at least since I looked at Zig, I think. I read about it because I was interested in the interoperability kind of stance that they take is very interesting. And they're like, you know what? You could just use Zig to compile C. We don't mind. That's fine. That was interesting, right? But I kind of came away with like, yeah, the standard library isn't there for this yet. And things are still moving on and pretty shaky as far as like moving around and stuff. So I didn't pursue it any further. All right. Passing to scope with the use. Okay, good. Having the right to mow can feel inconvenient and repetitive. Yes, and kind of just this is just kind of weird and gross and dumb what they've shown so far. We choose the absolute or relative path, add waitlist function every time. We want to call add to waitlist. We had to specify front of house and hosting too, right? Yes. Use keyword. Okay. Yeah. Hosting module into the scope of the eat a restaurant function, so we only have to specify hosting add to waitlist. Makes sense to me. Call the add the waitlist function and eat a restaurant. Yep. Use and a path in a scope is similar to creating a symbolic in a file system. I mean, I guess. Adding use crate front of house hosting in the crate root. Hosting is now a valid name in that scope. Okay. Just as though the hosting module had been defined in the crate root. Pass brought into scope with use. Also check privacy like any other pass. Okay. Use only creates a shortcut for a particular scope in which use occurs. 712 moves the eat at restaurant function into a new child module named customer, which is then a different scope. Then the use statements of the function body will compile. Okay, makes sense. So we went from just being here to going in there. Resolve module or unlink crate. All right. Use is no longer used in this scope. Okay, yep. Uh-huh. Okay. Might have wondered why we specified use crate, blah, 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 and then called hosting and the waitlist. Okay. Rather than specifying the use path all the way out to the add the waitlist function to achieve the same results as in this right here. Because it's less explicit, right? Use crate is probably an anti-pattern. I mostly use super 90% of the time, but I've heard people who don't like that. I've heard people, yeah. Heard of people who don't like it, yeah. Makes sense. Hmm. 711, 713 accomplish the same task. 711 is the idiomatic way to bring a function into scope with use. Bringing the function's parent module into scope with use means we have to specify the parent module when calling the function. Specifying the parent module when calling the function makes it clear that the function isn't locally defined. Yeah. While still minimizing repetition. That makes sense, right? It's explicit. It makes you aware. You're doing stuff. Hey, Terrace. Rust? Indeed. Indeed, Rust. On the other hand, structs, enums, and other items, it's idiomatic to specify the full path. What? A strong reason behind this idiom. It's just a convention that has emerged. Folks have gotten used to reading and writing Rust code this way. But why, though? Oh, no. Okay. Yeah. Hash map new. Right. That makes sense. The way they explained it, I thought it was backwards. Never destructure enums. It's never a good idea. What? The exception to this idiom is if we're bringing two items with the same name into scope with use. Right, that makes sense. Rust doesn't allow that. Why would it? Two result types into scope and the same name but different parent modules and how we refer to them. Right, that makes sense. Pretty standard stuff. Ba-da-ba-ba-da-ba-ba-ba. New names with the as keyword. Okay, yep. Also pretty standard stuff. I would predict you would like Zig more after learning Rust. Well, when Zig has people caring about it and thinking that it's cool if you know it for jobs, then maybe I'll think about it. Re-exporting names with pub use. Bring a name into scope with the use keyword. The name is private to the scope into which we imported it. To enable code outside that scope, to refer to that name, as if it had been defined in that scope, we can combine pub and use. Okay, that's kind of weird. But all right. Re-exporting because we're bringing an item into scope, but also making that item available for others to bring into their scope. Yeah. Fair point. I agree. Yeah, like I haven't seen anybody like outside of super niche examples like Terso care about Zig knowledge, right? Prefer type aliasing and new type to as. Okay, you say so. Like I don't understand the point you're trying to make. Like that's the whole reason I stopped learning Rust many years ago. Like I read the first couple chapters of this, had completely forgotten them pretty much. Like all I remembered was borrow checkers a thing basically, and things are immutable by default. But I stopped because at that time, the only place where Rust was seriously being used for like jobs that pay money was crypto, and I had no interest in that, so I didn't do it. I wrote some Rust in 2022. Nice. Okay. So we got that. External code would have had to call the add to waitlist function by using the path. All of this stuff required the front of house module to be marked as pub. Now this pub use has re-exported the hosting module from. Why would you need? Because of here? Yeah, because of here. Now that it has re-exported the hosting module from the root module, external code can use the path restaurant hosting at the waitlist. Okay. Like I have completely forgotten the structure that they had showed 3 pages ago here at this point. And I don't really understand the point that they're trying to make. Like, all I have taken away from this is you can re-export and then you import by this path instead. And maybe that's enough. As allows you to rename stuff, but you can do type this is result. Okay. I still don't understand like the difference. Like I have nothing to anchor that information to, right? Hopefully they'll explain it later. In chapter 137, where we discuss preferring aliasing to new type as. Okay, external packages. So we used Rand. Yes, we did. It went into TOML, right? But make Rand available to our project. Bring Rand definitions into the scope of our package. We added a use line. Okay, yes, like this. Generating a random number, we brought the RNG trait into scope and called the Rand thread RNG, right? Yes. Many packages available. Yep. Yep. Standard library is also a crate that's external to our package, which is crazy sauce to me, but okay. Standard library is shipped to the Rust language. You don't need to change cargo TOML to include STD. Oh no, never mind. Okay, I misunderstood what they were saying. But we do need to refer to it with use. To bring items from there into our packages scope, for example, with HashMap, we use this. Yeah, this makes sense. Yeah. Never mind. My mistake. Absolute path starting with standard. Yeah, standard library crate. Cool. Nested path cleanup use list. Okay. Here's you go to items. Same crate. Or same module. Listing each item on its own could take a lot of vertical space. Okay. Yeah. Nested paths bring the same items as a couple more. Okay. This is a pattern that's kind of emerging. This is just like a rustism. It looks slightly different in other places, like in the derives. It's a little different, but a lot of things can take a list of things I'm noticing. Okay. Reduce the number of separate use statements. Okay, yeah, yep. Use a nested path at any level in a path. Useful for combining two use statements that share a subpath. Yeah, gosh. One that brings standard IO into scope, standard IO right into scope. So we can do self. Okay, cool. And we can glob. Glob. Be careful when using the glob operator. Yep. Glob can make it harder to tell what names are in scope. Yep. Where your name is near program was defined. Yep. Plus, also, like, you usually don't need the whole friggin' package, right? Glob operator is often used when testing to bring everything under test into the test module. That makes sense, yeah. Chapter 11 for testing? Gosh, it's a million years away. Sometimes used as part of the prelude pattern. Okay. Okay, modules into different files. Hey. Drag modules into files. Yep. Instead of having them all defined in the crate root. Okay. Source librs. This procedure also works with binary crates whose crate root file is source main rs. Okay. Extract the front of house module to its own file. All right. Move the code inside the curly brackets for front of house module. Button right there. Here we go there. The mod front of house. Declaration. So that source librs contains the code shown listing 721. Won't compile until we create the source front of house RS. Oh no, this is either restaurant. Okay. The example lives on another page, so I can't see it at the same time and grasp the context of what you're trying to say. It's really hot in here. Okay. So then place it in there like we said it would be. Okay. Well, how else to look at this file? It came across the module declaration in the crate root with the name front of house. But can't you also put this into a front of house folder? Isn't that what they're saying? You'll need to load a file using a mod declaration once in your module tree. This compiler knows the file is part of the project, knows where the module tree of the code resides, because where you put the mod statement. Other files in your project should refer to the loaded file's code using a path where it was declared. What? Mod is not an include operation that you may see. Okay, well. Pick the hosting module. Place the file for hosting in a new directory that we name for its ancestors in the module tree. In this case, source front of house. Okay. That's what I was thinking they could do. Start moving hosting. We change this to contain only the declaration of the hosting module. Okay. Bop. Overstyle still supported. Source front of house hosting RS, what we covered. Okay. All right. We've made it. We've made it to chapter 8. Oh. Okay. First collection type, look at this vector of type, also known as a vector. Okay. More than one value next to each other in memory. Values of the same type. Yep. Makes sense. Vector new. Hell yeah, chapter 8. Type annotation here, right? Because you didn't put anything in here, so it can't infer, right? You aren't inserting any values into this vector. It doesn't know. Yeah. Vectors are implemented using generics. We'll cover how to use generics, your own types. Okay. Yes, yes, any type. Type in ankles. I32. Vec with an initial values, Russ will infer. Conveniently provides the vec macro, which will create a new vector that holds the values you give it. Okay. It's a default integer type, right? Bop, bop, ba-da, bop. Updating a vector. We can push. Change value, you need to make it mutable. Yep. Reading, we can probably just get the index, right? Indexing or using the get method. Oh, okay. Types of the values are return for these functions. So I'm going to guess that get will return an option, right? Indexing syntax in the get method. The third element is third. So 3. Third option, yes, vector get to. Also, if the third or is there's no third. Yep. Index value of 2 to get the third element because vectors are indexed by number. Yep. Using ampersand and brackets gives us a reference. Oh, yeah. Right there. To the element at the index value. We use the get method with the index passes argument. We get an option that we can use with match. Indexing will panic, which is anti-rust. Prefer get expect. You prefer get expect. What if I like the panic? What if I want the world to panic more? What if I bring chaos and panic and hatred? Okay, yep. We can use it match. 2 ways to reference an element, so you can choose how the program behaves. Yeah, makes sense, right? Vector 5 elements try to access element index 100 with each technique. Yeah. Panic, non-existent. You psychopath. Oh, there we go. I was getting scrunchy and hunchy and shrimping. I was shrimping. Okay. Yeah, it'll crash. Makes sense, right? And then the get is safer about it. That make like pretty standard stuff, right? Okay. Accessing an element beyond the range of the vector may happen occasionally under normal circumstances. Logic handle having either some or none. Yeah. Index coming from a person entering a number. Yup. Another chance to enter the valid, user-friendly. Yup. When you have a valid reference, the borrow checker enforces the ownership and borrowing rules to ensure that this reference and any other references to the contents of the vector remain valid. The rule that states you can't have mutable and immutable references in the same scope. That makes sense. Rule applies in listing 8.6 where we hold an immutable reference to the first element in a vector. In listing 8.6, all right here. Where we hold an immutable reference to the first element in a vector and try to add an element to the end. This program won't work if we also try to refer to that element later in the function. So first is a reference to you. This is mutable. Forces the ownership and borrowing rules to ensure that this reference and any reference to the contents of the vector remain valid. So this is allowed. Try to add an element to the end. This program won't work if we also try to refer to that element later in the function. This will get invalidated, is what they're saying. Immutable borrow occurs here. Cannot borrow V as mutable because it's also borrowed as immutable. Oh, because this is immutable reference. Right. Okay. Immutable borrow occurs here. Mutable borrow occurs here. That makes sense. All right. Hey, Justice, how's it going? Only if first is not held across the push. Right. Because a push could cause a realloc, resize, and thus make all references. Yeah. Makes sense. Immutable borrow later used here. Might look like it should work. Why should a reference to the first element care about the changes to end of vector? Yeah. Values next to each other. New element on the end of the vector might require allocating new memory, copying old elements to a new space. Yeah. Pointing to deallocated memory. Yes. Yes, indeed. All right. We can iterate for I in reference to V. For loop to get immutable references, and then immutable V gets us mutables. Okay. Good enough. Makes sense. Change the value that the mutable reference refers to. We have to use the dereference operator to get the value in I before we can use, because you've done this. Yes, that makes sense. Dereference comes later. Okay. Iterating over a vector immutably or mutably is safe because the borrow checkers roots. Okay. Attempted to insert or remove items in the for loop bodies 8.6 and 8.8. Get a compiler error similar to the one we got in the code list 8.6. Yeah. Reference to the vector that the for loop holds prevents simultaneous modification of the whole vector. Makes sense to me. Alternatively, v iter and v iter moot would also work there. I see. Bum 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 bum. Enum for multiple types. We talked about this, I thought. Vectors can only store values that are of the same type. Be inconvenient. Okay, sure. Yep. Variants of an enum are defined with the same enum type. So when we need one type to represent elements of different types, we can define and use an enum. Oh, okay, I see. Now I get it. We create a vector to hold that enum, and so ultimately hold different types. Yeah, yep. Rust needs to know what types will be in the vector compile time, so it knows exactly how much memory on the heap will be needed to store each element. You must also be explicit about what types are allowed in this vector. Rust allowed a vector to hold any type. There would be a chance that one or more of the types would cause errors with the operations performed on the elements of the vector. Enum plus a match expression means that Rust will ensure at compile time that every possible case is handled. Yeah. Enums and Rust are kind of tagged unions. Okay. If you don't know the exhaustive set of types, Burger will get a runtime to store in a vector. enum won't work, right? Use a trait object. Okay, we'll do that later. Common ways to use vectors. Refer to review the API. Well, not right now. I'm not gonna. Now is not the time to be reading API docs. Dropping a vector drops its elements. Okay. Makes sense, right? Bump, 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 bump. Okay. Strings. We talked about them. Look at them more. Rustaceous coming stuck on strings for a combination of 3 reasons. Propensity for exposing possible errors. Okay. Strings being a more complicated data structure than many programmers can give credit for, right? Yes. And UTF-8. Combined in a way that can seem difficult when you're coming up other programming. Discuss strings in the context of collections because strings are implemented as a collection of bytes. Yes. Plus, some methods provide useful functionality when those bytes are interpreted as text. Let's see. Operations on string. Every collection type has, such as CRUD, different from other collections. Indexing into a string is complicated by the difference between how people and computers interpret string data. Okay, sure. How dare they call them tagged unions? There's so much more. They're algebraic types. No. You stop that. Algebraic types leads to monads. Monads leads to functional broness. Functional broness leads to the dark side. Okay, so term string. Only one string type in the core language. Okay. String slice, stir. Do you know the Dear Functional Bros YouTube video? I do not. I do not. Okay. String slice. Yep. Borrowed form. String slice. We talked about string slices, which references to UTF-8 encoded data. Yep. String literals, binary, therefore string slices. All of that makes sense to my brain. Rather than coded in the core language as a growable, mutable, owned UTF-8 encoded string type. Yep. Strings, they could be talking about either. Yep. Usually the case. Okay. String new. All right. Then load the data. Okay. The toString. Yep. Any type that influences the display trait. Initial contents. Yep. String from. Yep. It's equivalent. Okay. Strings are used for so many things. We can use many different generic APIs for strings, writing with a lot of options. Some of them can seem redundant, but they all have their place. String from and string to do the same thing, so which one you choose is a matter of style and readability. Okay. Your own size, the contents can change, just like the contents of a vec. You push more data into it. In addition, you can conveniently use the plus operator or the format macro to concatenate string values. Ending with push string or push. You can grow a string by using the push stir method. Okay. This will contain foobar. Makes a string slice because we don't necessarily want to take ownership of the parameter. For example, in the code in listing 816, we want to be able to use S2 after appending its contents to S1. Okay, I see. Push-stir method took ownership of S2. Wouldn't be able to print its value on the last line. However, this code works as we'd expect. Push method takes a single character as a parameter and adds it to the string. What? What? Oh, okay. I see. Push versus push stir. Yes. And also sometimes you are generic over from two strings, so then it matters more, and that is more the main reason that both provided since they're parts of different interfaces. Generic over from two string. Oh. So like string from my struct thing is not gonna work, but two string, as long as I have that trait, will. That's what you're saying. Yeah. Okay. Single character. Concatenating with plus or format. String from hello world plus K. S1 is no longer valid after the addition. And the reason we've used a reference to S2 has to do with the signature of the method it's called when you use the plus operator. Plus operator uses the add method to signature, looks something like this. Self, and then an S, which is a reference to a string. Okay. Here's substituting concrete types, which is what happens when we call this method with string values. Yeah. Clues we need in order to understand tricky bits. Okay. That's a reference. Only add a second string slice to a string. Can't add two string values together. Type of S2 is a reference to a string and not a reference to a string slice. Specified in the second parameter add, so I'm listing it with compile. You're able to use string 2 and call in the call to add is a compiler can coerce the pointer to a string argument into a pointer to a string slice. Okay. Call the add method. Uses a deref coercion. Okay. Sure. Add does not take ownership. The S parameter S2 will still be valid string after separation. Okay. Add takes ownership of self because self does not have a reference ampersand. Means S1 and listing 18 will be moved into the add call, no longer be valid. Yeah. Actually takes ownership of S1, appends a copy of contents of S2, returns ownership of the result. Yeah. Concatenate multiple strings, behavior plus gets unwieldy. Sure, why not? And then we can just use a formatty. Formatty boy. Which is a macro. Okay. But instead of printing, it returns, yeah. Individual characters in the string by referencing them by index is a valid and common operation. It can be fraught. But to access parts of a string using index syntax in Rust, you'll get an error. Yep, okay. Indices are ranges of uses. Makes sense. It's a wrapper. Yep. 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 Uh-huh. Yep. Bop, 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 bop. Okay, yep. Text is hard. We know. I'm being summoned elsewhere. I'll try to get back if you're still on. Thank you for streaming. Yeah, may Clippy be with you. Well, thank you for hanging out. I hope you have a wonderful afternoon or evening, whatever it is there. I'm sure I'll be on. I'll be doing more editor stuff here later. We'll probably stop this. I'd like to get through 10. We'll see how long it takes though. And then we'll do some editor stuff. Somewhere today I'll have a lunch. And then I'll probably stream some Dune tonight. Because that was a really good time. All right. Tell you what, let me stretch out real quick. My nose is dripping for some reason. I'm gonna get a tissue and a beverage. I'll be right back. There we go. Get some water ready for when this monster's empty. I skipped the coffee this morning because it was just so hot. I didn't want a hot beverage. Okay, so invalid Rust code. Yep, not B3. Yeah. In Go, you have to, or you should, you can go through the indices of a string slice. You should use a rune, would be the correct answer. Okay, yeah. Blah blah blah. Text is hard. Text is complicated. We're good. Bop 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 bop. Okay, yeah. I'm just gonna. There we go. Okay. Rather than using this with a range to create a string slice containing particular bytes. Okay, but why? This seems like a bad idea as well. Try to slice only part of a character's bytes with something like hello. Yeah. Splice about whether you want characters or bytes. Okay, that makes sense. Yes. So we call dot cars. Okay. Two values of the type car. Yes. And then you can go through them and we get letters that I don't know how to pronounce. Or we can get the bytes if we care about that. Okay. Yep. Onward. Keys with values in Hashi maps. Hashi map key val. Okay. Yep. Uh-huh. Uh-huh. Blah 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 blah. There we go. Yep. Okay. Onward. New and to add elements. Okay, so hashi map new, like so, makes sense. Insert string from blue. Okay, so key and then value. Insert is the thing that we can use. First, use the hash map from the collection. Okay, yeah, duh. This one is the least often used. Okay. Less support from the state library. There's no built-in macro to construct it. Okay, whatever. It's like vectors, hash maps store the data on the heap. Keys are the type string, i.e. 32 values. There was no value specified, so it just has to, I guess, assume it when you do inserting. There are homogeneous keys must have the same type. All the values must have the same type. Okay. Presumably, you can shove an enum in there just like you could with a vector. It will infer it from context. Yeah. Mm-hmm. And then we have a get to try and get it. And we have some crazy stuff we don't know about yet. Yep, that works. Gotcha. Yep. Okay. It's key to the get method. So, ball, ba. Score will have the values associated with the blue team. Result will be 10. Get method returns an option. The reference to a value. There's no value for that key in the hash map. Get will return none. Handles the option by calling copied. Get an option I32 rather than option referenced I32. Why do I want to drop the reference? Then unwrap or to set score to 0 if scores don't have any entry for the key. Okay. Iterate over each key value pair in a hash map in a similar manner as we do with vectors using a for loop for key val in reference to scores. Makes sense. Each pair in an arbitrary order, right? Maps normally not guaranteed order. Managing ownership. With the copy trait, values are copied into the hash map for own values like string. The values we moved and the hash map will be owner of these values. Okay. Iterating over hash maps actually just produces tuple, so you just pattern match on that tuple in this example. Makes sense. Nothing special going on there. Yeah. Makes sense. We aren't able to use the values after we even moved in. Okay. Because the map must own the thing. Number of key and value pairs is growable. Each unique key can only have one value. Yes. Both the blue team and the yellow team could have the value 10. Yeah, right. Yeah, it's a map. It's a map. Replace the old. Keep the old and ignore the new. What? Only add a new value if the key doesn't. Okay, yeah. Combine the old value and the new value. Okay. So for overwriting, an insert will do it. Okay, makes sense. Adding it only if it's not present. He doesn't exist in certain value for it. Entry. Takes the key you want to check as parameter. return value of the entry method is an enum called entry. It represents a value that might or might not exist. So we want to check whether the key for the yellow team has a value associated with it. If it doesn't, we want to insert the value fitty. And the same for the blue team. Using the entry API, the code looks like listing 824. We create our map. We insert a blue 10. Scores entry, scores from yellow, or insert fitty. Is entry just like getting it out? Like you're just basically not assigning because you're using this instead to determine if there's something that comes out? That's what it looks like. Or insert method on entry is defined to return a mutable reference to the value for the corresponding entry key if that key exists. And if not, it inserts the parameter. Yeah, okay. Much cleaner than writing the logic ourselves. In addition, plays more nice with the bar checker. Okay. Yeah, you did. I don't know why. Do they object to I don't know what they object to in there. Okay. Naming is a bit confusing, but it makes more sense if you use it to get a value. Let entry, map entry, foo, or insert. Yeah. Yeah. Unique is much cleaner than writing logic ourselves. Oh, yeah. Okay. Yellow 50, blue 10. This blue is in there. Blue tomorrow instead of yeah, okay. Updating. There's also or insert with, which calls a function instead, which can be used to skip expensive creation of a value if it is needed. Okay, yeah. Updating value based on the value. So look up a key's value and then update it based on the old value. Kind of, I guess. Shows code that counts how many times each word appears in some text. Hash map with the words as keys and increment the value to keep track of how many times we've seen that word. First time we've seen a word, we'll first insert the value. Ugh. So text is you. Our map is our hash map for word and text split on the white space. Let count equal map entry word or insert 0. Count plus equals 1. We dereference you. And it gets returned to this. Right? So that this becomes no, I don't understand what's going on there. Entry returns a mutable reference to the value. Oh. Well, but this is still just like hanging out here. This is why I fucking hate that there's no control flow here, right? Like it's returning something, I guess, but where is it getting returned to? Like it's become very unclear immediately. No, it's not returning anything. Well, then what the hell is the point of count? Like, obviously it's supposed to be updating count, right? Okay. Yeah, okay. Well, that's easy to overlook. This is why this is dog shit to not have a return in this thing. Uh in the language, like to discourage it. Count is a mutable reference to the value in the hash map. Okay. But it wasn't even like you didn't say mute. It's very unclear. It's very unclear. Map entry word or insert. Because the reference itself is not mutable. But count is a mutable reference to the value in the hash map. Just pointing to a mutable thing. Yeah. This is a pain in the ass. So, counts how many times each word appears in some text. Hash map with the words as keys. Increment the value to keep track of how many times we've seen that word. If it's the first time we've seen a word, first insert the value 0. That's this part. You'd make count mutable if you'd want to be able to swap it out with another reference. But you're dereferencing it. Saying that whatever the value of count is right now, I want it to be more and more. This code will print this right here. Makes sense, right? I'd see the same key value pairs printed in a different order. Right, yeah, it's map. The split white space method returns an iterator over subslices. Yes, that makes sense. Separated by white space of the value in text. The orienter method returns a mutable reference, but it's not clear that it's doing that to the value for the specified key. Here we store that mutable reference in the count variable. So in order to assign out the value, we must first dereference count. Right. Mutable reference goes out of the scope at the end of the for loop. So all these changes are safe and allowed by the borrowing rules. Okay. Whatever the value that count is pointing to is right. Yes, I understand that part. Not count itself. In your editor, the LSP would add let count mute usize. Here. And we need to import you. Or I32, I guess. Yeah. Like it's doing some stuff here. But like it's still like this is very unclear. It's very hard unless you happen to know that this returns a mutable reference, even though this thing doesn't say it's mutable. You'll get used to it, maybe. This is a sharp edge. That's what I'm going with. Let's take you out of there. Just because we don't need you in this example. This is like almost as dog shit as Go's old habit of if you don't make a map, you have to actually call make on it. You'll get a nil reference if you try to immediately put a thing into it, and it'll panic, and it's dog shit. It's stupid. Or it used to be that if you iterated, oh, what was it? There was something to do with looping where the values would end up not being stale, basically. I can't remember. Compiler will complain if you aren't doing it right. But I shouldn't have to. I shouldn't have to get to the compiler, right? Like, the language should guide me to not being an idiot. The LSP should help guide me to not being an idiot. The compiler should catch if I'm being an idiot, for sure. Okay. Yes. Okay, yes. Hashing function called siphash. Okay. Okay. Sure. None of that matters, really. To hell with your introduction. Unrecoverable errors with panic. Sometimes bad things happen in your code. True, Rustbook. True. Nothing you can do about it. All right. We can panic at the macro. 2 ways to cause a panic in practice. Take an action that causes our code to panic. Like that. Or explicitly calling the panic macro. Cause a panic. Print a failure message. Unwind, clean up the stack, and quit. Okay. You can also have Rust display the call stack when the panic occurs to make it easier. Okay. Program starts unwinding, which means Rust walks back up the stack and cleans up the data from each function it encounters. Walking back and cleaning up is a lot of work. Allows you to choose the alternative of immediately aborting, which ends the program without cleaning up. Memory that the program was using will then need to be cleaned up by the operating system. If in your project you need to make the resultant binary as small as possible, and switch from unwinding to aborting upon panic by adding panic equals abort. Okay. To the appropriate profile sections, your cargo tom. Profile release, panic abort. All right. If you care about those extra kilobytes, like C and C++ and Rust devs tend to do, for reasons beyond me, let's try calling panic. No, let's not. It's good if you use the embedded. Yes, that's like a good reason. That is a valid concern on embedded where resources are very constrained. But often you see online people like, oh, look at that. The Rust binary is a whole megabyte, and this one is 16 kilobytes. I just don't fucking care. Only a few hundred KB of, application flash. But just like people like to just like shit on one another back and forth all the time with stuff like that, and it drives me crazy because it's just so stupid. Embedded, though, yes, that's a special case where it matters. For sure. Okay, crash and burn. Panicked, crash and burn. Okay. Line indicated, yep, okay. Bum, 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 bum. Someone else's code with panic macros called backtrace to figure out part of our code is causing a problem, right? Comes from a library. So if we access an out of bounds index, only 3 panic using K. Yes. Green element. Okay. Rust will stop and refuse. Okay. And then it'll say, hey, I panicked here because you did something kind of dumb. You should go fix your code. Set the rest backtrace. Yeah. Do. This of all functions that have been called to get to this point. Start at the top, read to see files you wrote. Lines above this spot. Yep. So for this example, we're way down here in library land, slice index, tool chains. And we keep coming. Alloc. Oh, source main. There we go. There's my code. That's where I did a stupid. Debug symbols are enabled by default when using cargo build, the cargo run without release. Okay. Yep. Okay. Yep. Don't usually want to panic. Makes sense. So we can result with an OK and error. I vaguely remember this. T represents the type of the value that we returned. In a success case with the OK variant, E represents the type of the error that we returned in a failure case within the error. Result is these generic type parameters. We can use the result type and the function defined on it in many different situations. With the success value and error value we want to return may differ. Function that returns a result value. Function could fail. Open a file. Okay. So greeting file result is U. Result type and error. So, okay. Type and error. T has been filled in by the implementation of file open. Success value. Standard FS file, which is a file handle. Otherwise, it's an IO error. Okay. If it succeeds, the variable result will be an instance of OK. Contains a file handle. Guess where it fails, it'll be an error. More info. So we can match on the result, decide what we want to do. Okay. Like the option enum, the result enum, and its variants have been brought in scope. Yeah. Prelude. Don't need to specify. When it's okay, code will return the inner file. Boop, right there. Value of the OK variant, and then we assign that file handle value to the variable greeting file. After the match, we can use the file handle for reading and writing. Okay. The other of the match handles the case where we get an error value from file open. Chosen to call the panic macro. No file name. Hello. Panic no matter why. Creates file, return the handle to a new file. Okay. Inner match expression. Yep. Error kind not found. Match file create halal. So we get another result back on the return or on an OK. We have a file. Problem creating the file if we fail. Otherwise, it's just a panic. FC. The hell does FC get used? I don't see where FC gets used. Am I blind? Don't worry, this can be expressed with less nesting. This is just an example using basic concepts. Yeah. File created. Where the hell is file created? Like, where do you get used? FC equals file. Right, I understand what his name is, but where does it go? Like, it looks like it goes out of scope and just is gone forever. Gets assigned to the greeting file by returning it from the match arms. So even if there's a comma, it'll still return. It needs a fucking return. That's what it needs. So you're saying it's going to come because there's nothing here. It's going to come back up to greeting file eventually. Even though we're in the error branch, we've decided that this is the error code. We're handling it. Yes. Okay. The type of the value that file open returns inside error variant is IO error. Struct 5 or standard library. Okay, makes sense, right? That's pretty standard naming. Has a method kind. Okay. So this actually comes from IO error, not from like a generic error type thing. IO error kind of, no, it is from the standard library. Okay. Correct. Okay, yeah. Representing different kind of errors that might result from an IO operation. Variant want to use error kind not found. Makes sense, right? Otherwise it'd be permission or something. Indicates file we're trying to open doesn't exist yet. We match on the result. Also have an inner match on error kind. Okay, so we match on the result. Also have inner match error kind. Whether value returned by error kind is the not found variant. Yep, of error kind. Try to create the file with create. However, this could also fail. We need a second arm in the inner match expression when the file can't be created. Different error message is printed. Yeah, okay. Second arm of the outer match stays the same as the program panics and on any error besides the missing file. Yeah, okay. That part I follow. Alternatives using match. It's a lot of match. Yes, it is. Closures, okay. Many of the methods defined on results. Closures in the unwrap or else. Code has the same behavior as 9.5. It doesn't contain any match expressions and is cleaner to read. Come back to this example after you read chapter 13. I will not remember, I promise. Many more of these methods can clean up huge nested match expressions when you're dealing with errors. Okay. Like this makes a degree of sense. So unwrap this result or else on an error. And then this is the closure. So that. Okay. Shortcuts for panic on error. Okay. Many helper methods. Unwrap method is a shortcut method implemented just like the match expression we wrote in listing 9.4. Which was you. Result value is the OK variant. Unwrap will return the value inside the OK. If it's the error variant, we'll call the panic macro for us. Okay. Unwrap in action. File open, hello text, unwrap. Run this code without a hello text file. We'll see an error message from the panic call that the unwrap method makes. Okay. So it'd be result unwrap on an error, blop, no file or directory. Cool. Expect methods also choose the panic error message. Expect instead of unwrap. Writing good error messages can convey your intent and make tracking down the source of a panic easier. Syntax of expect looks like this. Open, expect, should be included. Okay. That makes more sense now that I actually understand what the hell a result is better. Adjust this real quick. I crave more airflow upon me. Okay. Back the same way, unwrap, we'll call the panic. Error message is the parameter rather than a default. Panic at the macro. Section quality code. Most workstations choose expect rather than unwrap and give more context about why the operation is expected to always succeed. That way, if your assumptions are ever proven wrong, you have more information to use in debugging. All right. Propagating errors. Function implementation calls something that might fail. Instead of handling the error within the function itself, you can return the error to the calling code so they can decide what to do. This is known as propagating error, gives more control to the calling code. Yes. Where there might be more information or logic that dictates how the error should be handled than what you have available in the context of your code. Yeah. There's a function that reads a username from file. If file doesn't exist or can't be read, this function will return those errors to the code that called this function. That makes sense. So we open file result, blop. We do file or the error. New username string. File, read the string. Mutable reference to username. Do that, otherwise it's an error. Oh, okay. You're saying we returned it here, but not there. Function can be written in a much shorter way. Can you scroll a bit? Oh, yeah. Sorry. It is on the half where I am for sure. Function can be written in a much shorter way. We're going to start by doing a lot of it. Okay. Manually in order to explore error handling at the end. Show you the shorter way. All right. Function is returning a value of the type result t, right? Yes. Result type error. Generic parameter T has been filled in with the concrete type string, and generic type E has been filled in with the concrete type IO error. Makes sense. Function succeeds without any problems. The code that calls this function will receive an OK value that holds a string, the username. Shoop, right there. Username file, or actually, it's going to actually end up being this, right? Whatever the return is that is. Okay, value holds a string. The username as its function ready for the value file. Yes. If this function encounters any problems, the calling code will receive an error value. It holds an instance of IO error that contains more information about what the problems were. We chose IO error as the return type of this function because that happens to be the type of the error value return. Right. I mean, it is an IO error, right? For both the operation we're calling this function's body that might fail. File open function, the read string. The value of the last match expression. Yeah. Body of the function starts by calling the file open function. Handle result value with match. File open succeeds the file handle the pattern variable. File becomes the value in the mutable variable username file. Mutable username file. That. Yes. Function continues. In the error case, instead of calling panic, we use the return keyword to return early out of the function entirely, pass the error value from file open. Pattern variable E. Back to the calling code. That's this function's error value. Pass the error value from file open now in the pattern variable E. Duh. Yes, I see. Um, right there. Back to current code. Okay. So if we have a file handle, the username file, the function then creates a new string in variable username, calls read the string method on the file handle in username file to read the contents of the file into username. Yep. Also returns a result because it might fail even though file open succeeded. So you need another match to handle that result. If read string succeeds, that function has succeeded, and we return the username from the file. That's now in username wrapped in an OK. If read the string fails, we return the error value in the same way. Return the error value in the match that handled return value of file open. However, we don't need to explicitly say return because this is the last expression in the function, but you should, you absolute monsters. Code that calls this code will then handle getting either an OK value that contains a username or an error. Yeah. Up to you to decide what to do. Could be panic, could be something else. It could even be a boat. Propagating errors is so common in Rust that Rust provides the question mark operator to make this easier. I mean, that makes sense, right? Very commonly, you need to just report up and you decide how you want to think about what just I told you. All right, so the question mark shortcut. I guess just means return my thing or an error. And then username is string new, file, read the string. If it's an error, return it. Otherwise, it's an OK with the username in it. Defined to work in almost the exact same way as the match expression that we defined to handle result values. Value of the result is an OK. Value inside the OK will get returned from this expression, and the program will continue. If the value is an error, the error will be returned from the whole function as if we had used the return keyword, but the error value gets propagated to calling code. All right. Difference between what the match expression from listing 96 does and what the question mark operator does. Error values that have the question mark operator called on them go through the from function, defined in the from trait and the same. Which is used to convert values from one type into another. And the question mark operator calls the from function. The error type received is converted into the error type defined in the return type of the current function. Okay. Useful when any function returns one error type to represent all the ways a function might fail, even if parts may fail for many different reasons. Yeah, okay. Yeah, I see it. Scroll request. Maybe I should just maybe I can be over here today. Normally I'm in editor code and not just a web page, so. Okay. Fighting the sleepies real bad today. The hot, sticky weather. I just want to go take a nap. Okay, so we change the read username for file function to return a custom error type named our error that we define. If we also define the impl from IO error from our error or for our error to construct an instance of our error from an IO error, then the question mark operator calls in the body of read username from file will call from convert the error types without needing to add any more code to the function. From IO error. Impl from IO error for our error to construct an instance calls in the body of read using file will call from and I'll convert the error types that need to add any more code to the function. Oh, because you're still returning an IO error. I see. You'll see more on that in section 10. Like I understand that it's hard to wrap all this into like a digestible split up chunk. But it's a fucking meme at this point in this book to say you'll read more later. You'll read more later. You'll read more later. And it's really frustrating because you feel like you're getting half of a story all the time. In the context of listing this 9.7 blah up there, end of the file open, call return the value inside an OK to the variable username file. Right? Yes. An error occurs, the question mark operator return early out of the whole function and give any error value to the calling code. The same thing applies to the question mark at the end of the read string call. Write your own better Rust book and propose to that instead of as the official one. Well, then I have to become a Rust expert first. You see, you've raised the bar. Question mark operator eliminates a lot of boilerplate, makes this function's implementation simpler. You can shorten this code further by chaining method calls immediately after the question mark, as shown in listing 9.8. Okay. Hmm. Move the creation of the new string and username to the beginning of the function. Part hasn't changed. Instead of creating a variable username file, change the call. Yeah. I understand what we're doing. I don't know if I'll use it or remember how to use it, but I understand it. FS read to string. Okay, yeah. Let's do that. That seems way easier. Seems like I don't even need this shit at all. Okay. Doesn't give us the opportunity to explain all the error handling. Yep. Yep. Now I get you. I understand. Reading a file into a string is kind of a common operation, so as a helper. Yeah. Yeah, it makes sense. But like I also get why they broke it down like that. Only be used in functions whose return type is compatible with the value the question mark is used on. So it has to return a result that you matches your thing. Trying to perform an early return of a value out of the function in the same manner as the match expression we defined back then. Matches using a result value, and the early return arm returned an error E value. Return type of the function has to be a result so that it's compatible. Yeah, makes sense. Error will get if we use you in the wrong way. So we did that. Main doesn't return anything though. Returns result or option or another type that implements from results. If your function returns result TE, the value you use it on needs to be result UE2, where E from yeah. Yeah. Um Only allowed to use the question mark operator in a function that returns result option or another type that implements from residual. Okay. Change the return type of your function to be compatible with the function you're using the question mark operator on, as long as you have no restrictions preventing that. Use a match or one of the results methods to handle the result in whatever way is appropriate. Okay. Question mark can be used the option T values as well. As with using a question mark on result, you can only use a question mark on option in a function that returns an option. Okay, yeah. Behavior of the question mark operator when called on an option T is similar to its behavior when called on the result T E. Value is none. The none will be returned early from the function at that point. Value sum. Value inside the sum is the resultant value of the expression, and the function continues. Finds the last character of the first line in our text. So lines next question mark cars last. Okay. Hmm. Alternatively, it also works with functions returning option T and values of type option Z. It's too many letters. It's too many letters. And then their option, cool. Yeah. Next, bang. It'll be a not a thing. And then otherwise we'll get the characters. String, slice, argument, lines, iterator, blah, blah, blah. I'm just not even going to read that. So for all the main functions we've used return the chungus, aka the unit. Main function is special because it's the entry point and exit point of an executable program. There are restrictions on what its return type can be for the program to behave as expected. Main can also return a result of chungus E. Listing 912 has the code listing. Yeah, okay. Change the return type of main to be result, Chungus, box, dynamic error. Added a return value. Okay to the end. This code will now compile. So file open, question mark. Okay. If it's okay, we give it a Chungus. Meant to type U, but accidentally type Z. They're next to each other on a German keyboard. For maximum efficiency in typing oots, 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 right? Yeah. Okay. Boxed in error is a trait object, which we'll talk about, okay, later. Any kind of error, okay, yeah. Question mark on a result value in a main function with an error type that is allows any error value to be returned early, even though the body of this main function will only ever return errors of type standard IO error. By specifying this, signature will continue to be correct, even if more code that returns other errors is added to the body of main. When a main function returns a result with an error, executable will exit if with a value of 0 if main returns OK, which is just the unit, and will exit with a non-zero value if main returns an error value. Okay. Executables written in C return integers. Yes, they do. Return the integer 0. Error returns some integer other than 0. Rest also return integers from executables to be compatible with this convention. Main function may return any types that implement the termination trait, which contains a function report that returns an exit code. So the standard library documentation later. All right. Unit is the proper way to say Chungus. Is that what you're saying? You have been terminated. Maybe that sounds wrong. You've just been terminated. I'm out of practice on my Arnold. Okay. Panicking. How do you decide when you should call panic at the macro? No way to recover. Yep. Pretty normal. Making the decision that a situation is unrecoverable on half of the calling code. Give the calling code options. Yeah. 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 Okay, type code and tests. It's more appropriate to write code that panics. Yeah, okay. Uh, 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 uh. All right, yeah, uh-huh. Okay. Appropriate to call expect when you have some other logic that ensures that the result will have an okay value, but the logic isn't something the compiler understands. You'll still have a result value that you need to handle. Whatever operation you're calling still has the possibility of failing in general, even though it's logically impossible in your particular situation. You can ensure by manually inspecting the code that you'll never have an error variant that's perfectly acceptable to call expect, and document the reason you think you'll never have an error variant in the argument text. Here's an example. Okay. See that 127.0.0.1 is a valid IP address, so it's acceptable to use expect here. Having a hard-coded valid string doesn't change the return type of the parse method, right? We still get a result value Compiler will make us handle the result as if the error variant is a possibility. Compiler is smart enough to see that this string is always valid IP address. Makes sense to me. And all of this is just like normal error handling stuff. Custom types for validation. Valid value, one step further. Custom type validate for validation. We had a guessing game. Yep. Never validated that the user's guess was between those numbers before checking it against our secret number. Only validated that the guess was positive. Okay. Consequences were not very dire. Our output of too high or too low would still be correct. Yeah, useful enhancement to guide the user toward valid guesses and have different behavior when the user guesses a number that's out of range versus the user types, for example, letters instead. Parse the guess as an I32 instead of only a U32. Allow negative numbers, add a check for the number being in range. Yep. We can proceed to comparison. Okay. Not ideal if we're absolutely critical that the program will only operate on values from 1 to 100. Had many functions within this requirement. Having a check like this in every function would be tedious and might impact performance. Okay. New type in a dedicated module. Put the validators in a function to create an instance of the type rather than repeating the validations everywhere. Safe for functions to use the new type in their signatures and confidently use the values they receive. 913 shows one way to define a guess type that will only create an instance of guess if the new function receives value between 1 and 100. So you impl, it's a new, we get the erroring or the panicking out of the way. That's not a good place for a panic, though. Struct name guess, field name value, holds an I32. Bum, 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 bum. Make sure it's in 1 and 100. It doesn't pass. We make panic. Oh. Conditions in which guests knew might panic should be discussed in its public-facing API documentation. Okay. Implement a method named value that borrows self. Doesn't have any other parameters, returns an I32, which is you because value is not public. Sometimes called the getter. Yep, because its purpose is to get some data from its field and return it. Public method is necessary because the value field the guest struct is private. It's important that the value field be private so that the code using the guest struct is not allowed to set value directly. Yep, makes sense. Must use the guest new function. All of that checks out. Alternatively, one common other method there would be try new result self out of range here or something. Yeah, it makes sense, right? Yeah, it's a crappy way to like they just told us a common mistake shouldn't really be a panic. And then immediately made a common mistake be a panic, which is a less good solution than they had just suggested. Kind of funny. All right. Generics. We're going to power through this and then we're going to do something else. Every programming language has tools for effectively handling the duplication of concepts. One such tool is generics. Yep. Parameters is some generic type instead of a concrete type. Okay. Or did you use generics chapter 6 with option T? Chapter 8 with the vector T, hash map KV, chapter 9 with result TE. Okay. How to extract a function to reduce code duplication. Okay. Same technique to make a generic function from 2. How to use traits to define behavior generic way. Traits with generic types to constrain a generic type to accept only those types have a particular behavior, as opposed to just any type. Lifetimes come last. Okay. Generics allow us to replace specific types with a placeholder that represents multiple types to remove code duplication. First, look at how to remove duplication in a way that doesn't involve generic types. Okay. Extracting a function replaces specific values with a placeholder, represents multiple values. Same technique to extract your generic function. Okay. So, you have a program, finds the largest number in the list. Okay, makes sense. Number is greater than largest. Largest is the number. At the very end, we print out whatever is largest. We borrow the number list so that we go through it and it's not eaten. Store a list of integers in the variable number list. Yep. Reference the first number in the list in a variable named largest. Yep. Iterate through all the numbers. Blah, blah, blah. Yeah. All that stuff I just said. Choose to duplicate the code in listing 10.1 and use the same logic. But we wouldn't want to. That makes no sense. We're going to make a function for it. Like, yeah, that right there. All of that makes sense. Very common. All right. In defining a function that uses generics, we place the generics in the signature of the function. I would usually specify the data types of the parameters and return value. Okay. It also makes our code more flexible and provides more functionality to callers out of our function while preventing code duplication. Continuing with our largest function. Two functions that both find the largest value in a slice. We'll then combine these in a single function that uses generics because we have an I32 and a character list. Okay. I see. Um One common other method there would be try new result self out of range error or something. Oh yeah, I read that. More common way to do this would just be to use let largest is number list iter max. I mean, sure, but then you wouldn't learn nothing. Okay, so then we have largest I32, largest char. Makes sense. And I guess we're allowed to just list of characters. Okay, yeah. Because they're characters, they're not full. It's not a rune in a string. Okay. Yep, that one. Largest char in a slice. Same code. Parameterize the types in a new single function. We need to name the type parameter. So we do for the value parameters to a function. Any identifier as a type parameter name, but we'll use T because by convention, type parameter names in Rust are short, often just one letter. Sure. Upper camel case, short for type T is the default choice of most Rust programmers. Okay. When we use a parameter in the body of the function, we have to declare the parameter name in the signature so that the compiler knows what the name means. Makes sense. When we use a type parameter name in the function signature, we have to declare the type parameter name before we use it to define the generic largest function. We place type name declarations inside angle brackets. Yes. Between the name of the function and the parameter. Yeah, this is very common. Syntax makes sense. So largest of a type. It's a list of references to same type, returns a reference to a type. Read this definition as the function largest is generic over some type T. This function has one parameter named list, which is a slice of values of type T. The largest function return a residue value. Yeah. What I just said. Okay. Shows the combined largest function definition using generic type. Yeah. Okay. So we go through, we do the thing. They both call largest. We'll get an error. Can it be applied to type of reference to T? Help text message mentions standard to compare partial ORed, which is a trait. We're going to talk about traits in the next section. Note that this error states that the body of largest won't work for all possible types that T could be. So we want to compare values of type T in the body. We can only use types whose values can be ordered. To enable comparisons, the standard library has the standard to compare partial ORed trait that you can implement on types. Okay. Restrict the types valid for T to only those that implement partial ORed. Will compile because the standard library implements partial ORed by I through 2 and char. So where's my example that shows me in nice clear ways what you're talking about? Okay, so they would literally just look like that. But then oh, okay, I see. I follow now. That's basically it. Gotcha. Also define structs use generic type parameter in one or more fields using the two alligators fighting syntax. Okay, so defines a point T struct to hold X and Y coordinate values of any type. So point T, X and Y are both T. You could do a float, you could do an int. Syntax for using generics in struct definitions is similar to that used in function definitions. Declare the name of the type parameter inside the angle brackets just after the name of the struct. Use generic type in the struct definition where we otherwise specify concrete types. Okay. When we use one generic type to define point T, this definition says that the point T struct is generic over some type T. X and Y are both that same type. That makes sense. Whatever it may be. We create an instance of point T that has values of different types, as in 10.7, our code won't compile. Makes sense, right? How are you going to be a point of integer type if you got a float in you? All right. Adjust that real quick. Lean back because I'm shrimping. To define a point struct where X and Y are both generics but could have different types, we can use multiple generic type parameters. Okay. So T and U. You want a stretch? I could use a stretch, I suppose. I did feel good. That did indeed feel good. Let's see here. Okay, so we can use generics T and U. Okay, X is the type T and Y is the type U, and then we can say that you're a crazy thing for reasons unknown. Now, all instances of points shown are allowed. As many generic type parameters in a definition as you want. Using more than a few makes your code hard to read. If you're finding you need lots of generic types in your code, it could indicate that your code needs restructuring into smaller pieces. I maybe wouldn't do that for a point specifically, but it works, right? Yeah, it's super cray cray for. Well, I guess if you cared, like technically, a vector is supposed, like in math, right? Is supposed to have a magnitude or whatever, right? So like a direction and a distance, if I'm remembering correctly. So maybe it makes sense not to round that distance in your world, in which case a point could have an X, Y, and a V or something, and that might make sense, I guess. You could restrict it in methods. Yeah, you could. I think this example is crazy town, but it could come up. I could do enums as well. Okay. It's not completely infeasible. Yeah, just mostly infeasible, I guess, right? So option T num is generic over type T has two variants, some which holds one value of type T and a none variant that doesn't hold any value. Well, this is just result all over again. Or not result. The other one. No, yeah, result. Yep. No. Because error. The one you use unwrap on. What's it called? Option. It is option. Wasn't reading the actual name of it. You can unwrap both. Right. Right. Not unwrap. The other one, right? I don't know. Doesn't matter. Okay. Generic of two types T and E has two variants. Okay. Holds value of type T in air. Holds the value of type E. If you need to use the result enum anywhere, we have an operation that might succeed, right? Used to open the file. Yep. It's more of a semantic difference. Option is more used when the none case is expected and not an error. Okay, yeah, that makes sense, I guess. In method definitions, we can implement a type of a point type. Function X is self, return the type, reference to self X. Okay. Method named X and point T turns a reference to the data in the field. After declare T, just after impl, so that we can use T to specify that we're implementing methods on the type point T. Declaring T is generic type after impl. Rest can identify the type in the angle brackets in point. Generic type rather than concrete type. Could have chosen a different name for this generic parameter than the generic parameter declared in the struct definition, but using the same name as conventional. You write a method within an impl that declares a generic type. That method will be defined in any instance of the type, no matter what concrete type ends up substituting for the. Okay, yeah, sure. Like this has gone. Like they're really getting into like the I'm a language nerd, levels of fucking description here. Constraints on them, methods only on point F32, so that you can only get this on something with a float. And then you get your powies and your squirts all squared away. Type point F32 will have a distance from origin method. Other instances of point T where T is not of type F32 will not have this method defined. Yeah. Yeah. Mm-hmm. Strict definition are always the same as those you use in that same structs method signatures. Think someone just received squirt damage. Marco had to go someplace else. Maybe he'll catch the VOD and get some squirt damage. Ugh, like this has become so dense and difficult to follow. Okay, so generic type X and Y, one for point struct. X2 and Y2 for the mix-up method to make the example clearer. Method creates a new point instance with the X value from the self point. Okay, no, no, just fuck off. Performance. Generic types won't make your program run any slower than it would with concrete types. Monomorphization of the code. Oh my god. It doesn't change the performance. We're done. Fuck off. Oh my god. Shared behavior. Okay. Like get to the point. Holy shit. Generates foo i32 foo f64 versions of your functions. Okay. Calling generic ones with a concrete type. It became like 9,000 lines of shit and a complicated description. So like it at some point you just have to put fucking comments in a code block and let the code express things, you know? That's one of the main problems with their stuff. It's complicated but also accurate. I don't give a shit is the problem. It was made so hard to follow that I just said I don't fucking care. Like it descended into like my passion is designing language shit and I love type systems. And I don't care. I want to know how to correctly hold the hammer and make a thing. I'll figure it out later when it matters. That's what I'll do. Okay, so traits. Feature often called interfaces. Okay, so like that would have been great to know way sooner. Just saying. So a trait type's behavior consists of the methods we can call on that type. Okay. Different types share the same behavior. If we can call the same, yeah, it's an interface in that regard. Makes sense. Find a sign of set of behaviors necessary. Yeah, okay. Multiple structs that hold various kinds of amounts of text. A news article struct that holds a news story filed in a particular location, and a social post that can have at most 280 characters, along with metadata that indicates whether there's a new post, a repost, or reply to another post. Take a media aggregator library crate named aggregator that can display summaries of data. Might be in either of these. A summary from each type. So you'd say you need an interface normally. Request that summary by calling a summarize method. Yeah, okay. Shows the definition of a public summary trait that expresses this behavior. Okay. Summary means you need a function to summarize. Reference to self gives me a string. That's basically me. Which part? The type system loving hot turbo language nerd. The argument type, yeah. I've noticed that it seems to be in your wheelhouse for sure. But like I don't care. You know, you're arguing about the proper composition of the sand you've placed inside of the dead blow hammer and how the microscopic crystalline structure does all the physics things. And I'm like, man, I want a good hammer. I want to build some shit with it. Does this thing help me do that? That's what I want to know. I have zero. I'm glad there are people who care about that kind of thing because they build languages, right? But I have zero fucks to give about it. Okay, so yeah, trait summary, cool. Which is summary. It's a pub, so other things can use it. Inside the curly brackets to clear the method signatures. Describe the behaviors. Just like an interface so far. Semicolon. Yep. Uh-huh. Okay. Implementing a trait type. Now we go. Desired signatures, let's implement on types, intermediate aggregator, implementation of the summary trait. News article struct uses the headline, the author. Yeah. Okay. Shut up. Show me code. Implement summary for news article. It follows the signature, and I spit out a nice little string using format. Bop. Social post, same deal. Username, content, bop. Cool. Perfect. Trait name and for you. Okay. So that's, I guess it is kind of different, right? Just slightly. Main difference with the interfaces is that if you have interface A with method foo and interface B with method foo as well, these would be the same method with interfaces, but with traits, methods are specific to a specific trait. Okay, yeah, I follow. So like if you had a different thing that wanted to summarize, it wouldn't implicitly implement the interface, basically summary. If you had one that was identical called foo summary, whatever. Which, like, initially I wasn't a huge fan. It wouldn't be the same summary. Yeah. Initially I wasn't a huge fan of Go's implicit interface implementation. But after using it for a while, I came around on it. And I was like, yeah, it is pretty nice. And as long as your IDE helps you to know and helps you out with that, it's pretty good. Okay. In the impl block, we do the things that are impl things. You can forward the call to the other trait if you want to, but that would be, yeah, that'd be explicit. Yeah. Yeah, no, we can go, like, if you give your thing a stringer just because you want to spit it out later, in a better way, your IDE will come up with like a little interface thing, and yeah, you just implement like 4,000 interfaces. It's cool. Not really that many, but a whole bunch of them will be implicitly implemented just because you have a stringer. It's funny. Okay. Rust is more explicit in that sense, yeah. And like I said, initially I was a little bit, I don't know if I like this, but I came around. It is kind of nice. Okay, so now we've done that, and then we can just call summarize on you. That's like an interface. Okay. Horse ebooks. Love it. Okay. Anything else that depends on the aggro, can also bring the summary trait into scope. Yeah. Default implementations. Oh, you can give summaries, traits a default. Okay, interesting. I wonder if you can specify parameters or not. New article available, read more. Because of that. Um Specify an empty impl block. Just to say give me the default. Okay. Specify parameters like you hang these off of structs, right? So can you say that uh a thing that requires a summary must have a author string, for example, without saying it must have a get author string to sort of like require that property without requiring it? A field. It's only trait based. Okay. Fields are implementation specific. Right. But they didn't they don't have to be technically. And like I said, you can get around that by saying you must have the get author. Yeah, exactly. Get author trait. Exactly. That's what you got to do usually in a lot of different, like in Go, if you want to do something like that. To just basically make sure that anything that satisfies this interface also has this property that you care about for some reason or another. But that's just like it adds complexity. It would be nice sometimes to say, you know what, it needs to have an author field that I can access. And then if it's public, then it would satisfy. And if not, then it wouldn't, right? But that doesn't exist. It's probably bad idea in some way, shape, or form. But anywho, default implementations can call other methods in the same trait, so we can do that. Summarize author and then summarize. I guess I skipped probably too much. Usually don't do that in Rust, though. That's usually an indication of bad design. I mean, yeah, maybe. It's come up very rarely where I wished it would exist. Um, Empty input block. Okay, yep. No longer defining. Yep. Uh-huh. Default implementation doesn't require us to change anything about the implementation of summary on social post. Reason that the syntax for overriding a default implementation is the same as syntax for implementing a trait method that doesn't have a default implementation. Call other methods in the same trait, even if those other methods don't have a default implementation. That seems like a weird way to go about it. Only require implementers to specify a small part of it. We could define the summary trait to have a summarize author method whose implementation is required. Define a summarize method that has a default implementation that calls a summarize author method. Okay. You can kind of see it, yeah. Only to define summarize author when we implement the trait on a type, because this will just be implicit, basically. After we define summarize author, we can call summarize on it. Yep. One new post, read more from Horsey Books. Cool. Trait says parameters. Find functions accept many different types. Summary trait we implemented in the article social post types in listing 1013. Define a notify function calls the summarize method on its item parameter, which is some type that implements the summary trait. To do this, we use the impl trait syntax like this. So we call item summarize on the thing. I take an argument, a reference to a thing that implements summary. Concrete type for the item parameter. Yeah, okay. All right, easy enough. Trait syntax works for straightforward cases, but actually syntax sugar for a longer form known as trait bound. It looks like this. T summary item in T. Okay. Longer form is equivalent to the example in the previous section, but is more verbose. We place trait bounds within the declaration of the generic type parameter after a colon and inside angle brackets. Okay. Impl trait syntax is convenient, makes for more concise code in simple cases, while the fuller trait bound syntax can express more complexity in other cases. So you can do that, or you can do that. All right. Specify more than one trait bound. So summary plus display, summary plus display, not a comma separated list here. With where clauses. Functions with multiple generic type parameters can contain lots of traits bound information. The function's name is parameter list, making the function's signature hard to read. For this reason, Rust has alternate syntax for specifying trait bounds inside a where clause after the function's signature. Instead of writing this mess, you do T and U, where T is a display plus a clone, and U is a clone plus a debug. Okay. Types that implement traits, we return the impulse summary. Okay. Do. Impl trait if you're returning a single type. Use article or a social post with the return type specifies the impl summary won't work. Oh. Isn't allowed due to restrictions around how the impl trait syntax is implemented in the compiler. Okay. We'll do this later. Using trait bounds to conditionally implement methods. Trait bound with an info block uses generic type parameters. Implement methods conditionally for types that implement. Oh my god. What are you trying to say? Pair T only implements the compare display method of the enter. Oh my gosh. So struct pair of a type. Type implements a pair of a type. Turns self. A new X and Y. Display needs to implement the partial ORD. Always implements a new function. Return a new instance of pair T. I don't know what the hell they're trying to say. Don't care. Moving on. The two notify methods there are not actually the same. What are you talking about? Here? Upper ones? Why not? First one, they can be different types. Oh, okay. Well, they should be the different types here too, though, right? Because as long as it implements the summary. Oh no, okay. All right, whatever. I don't know, dude. Like this thing has drawn on so long. I'm so fucking done with their generics fucking documentation. Both her T and a single generic can only be substituted. Okay, makes sense, I guess, in a way. All right, so like this section is why type systems get a fucking bad rap, dude. I tell you. Like so much fucking navel gazing has gone on in this thing. Okay. Lifetimes. Rather than ensuring that the type has the behavior we want, lifetimes ensure the references are valid as long as we need them to be. To discuss in reference to borrowing section. Every reference has a lifetime, which is the scope. Okay. Lifetimes are implicit and inferred. It's kind of important, so I'd advise you to pay attention here. Well, then they should spit out in clear language what the hell they mean. We'll find out. Implicit and inferred, right? Yes. Types are inferred. Okay. Only required to annotate types when multiple types are present. Okay. Annotate lifetimes when the lifetimes of references could be related in a few different ways. Rust requires us to annotate the relationships using generic lifetime parameters. Oh my god, okay. Not even a concept most other programming languages have, so it's going to feel unfamiliar. Yep. Makes sense. Although we won't cover lifetimes in their entirety in this chapter, we'll discuss common ways you might encounter lifetime. Okay, go far. Done with the summary. Prevent dangling references. Cause a program to reference data other than data it's intended to reference. Consider this outer scope and an inner scope. let our inner scope, this theoretically would shadow, but then this tries to be a reference to that, which this goes out of scope, and then we're in trouble. Let's see here. Declare variables without giving them an initial value. So variable names exist in the outer scope. Might appear to be in conflict with Rust having no null values. However, if you try to use a variable for giving it a value, we'll get a compile time error, which shows that indeed Rust does not allow null. Okay. Outer scope declares a variable named R with no initial value. Yep. Inner scope declares a variable named Rx with the initial value of 5. We attempt to set the value of R as a reference to X. Inner scope ends. We pretend to print it. Won't compile because the value that R is referring to has gone out of scope before we try to use it. Here's the error. X does not live long enough. I feel you, X. I feel you. The error message says that the variable no shit. Is that what it says? X will be out of scope, right? Makes sense. R is still valid for the outer scope. Again, makes sense. Lives longer. Okay. Borrow checker. All right. Compare scopes to determine whether all borrows are valid. Okay. Okay, yeah. 1018 fixes the code so it doesn't have a dangling reference and compiles without any errors. So we assign you to a thing. We say that you're a reference there. Well, yeah, okay, there's no scope funkiness going on. That makes sense. Write a function that returns the longer of two string slices. Take two string slices, return a single string slice. After we've implemented the longest function, the code in 1019 should print the longest string is ABCD. Okay. Result is longest string 1 as stir, string 2. Want the function to take string slices, which are references rather than strings. Don't want the longest function to take ownership of its parameters refer to string. Yeah, okay. Try to implement the longest function as shown, it won't compile. This turns that. Say we get the following error that talks about lifetimes. Expected named lifetime parameter. Because we're trying to give it back a reference here, but it'll go out of scope because here we have that reference that goes away. Needs a generic lifetime parameter on it. Can't tell whether the reference being returned refers to X or Y. We don't know either because, yep. No, it won't go out of scope. Don't know whether the if case or the else case will execute. Also don't know the concrete lifetimes of the reference that we passed in. So we can't look at the scopes as we did in those listings to determine whether the reference we return will always be valid. Our checker can't determine this either because it doesn't know how the lifetimes of X and Y relate to the lifetime of the returned value. Fix this error will add generic lifetime parameters. Find the relationship between the references so our checker can perform its analysis. It returns a parameter, so it's fine. This says it doesn't compile. Says it's supposed to give you this. Signature is not fine. The body of the function is. Well, yeah, that's the point they're trying to educate us on. Lifetime. Yes. Lifetime annotations don't change how long any of the references live. Rather, they describe the relationships of the lifetimes of multiple references to each other without affecting the lifetimes. This function can accept any type when the signature specifies a generic type parameter. Functions can accept references with any lifetime by specifying a generic lifetime parameter. Lifetime annotations have a slightly unusual syntax. The names of lifetime parameters must start with an apostrophe, are usually all lowercase and very short. Okay. Use the name A for the first. Lifetime parameter annotations after the ampersand of a reference, using a space to separate the annotation from the references type. Okay. So, you. Reference to an I-32 without lifetime. Yeah, okay. One lifetime annotation by itself doesn't have much meaning, but because the annotations are meant to tell Rust how generic lifetime parameters of multiple references relate to each other. Okay. Function signatures. You declare the generic lifetime parameters inside angle brackets between the function name and the parameter list, just as we do with generic type parameters. Want the signature to express the following constraint. The returned reference will be valid as long as both of the parameters are valid. Okay. This is the relationship between lifetimes of the parameters and the return value. We'll name the lifetime A and then add it to each reference as shown in 1021. Code should compile and produce a result we want. We use it with the main function in listing 1019. Now it tells Rust that for some lifetime of A, the function takes two parameters, both of which are string slices that live at least as long as lifetime A. Function signature also tells Rust that the string slice returned from the function will live at least as long as lifetime A. Practice, it means that the lifetime of the reference returned by the longest function is the same as the smaller of the lifetimes of the values referred to by the function arguments. Relationships are what we want Rust to use when analyzing this code. Specify the lifetime parameters in this function signature. We're not changing the lifetimes of any values passed in or returned. We're specifying that the borrow checker should reject any values that don't adhere to these constraints. Longest function doesn't need to know exactly how long X and Y will live, only that some scope can be substituted for A that will satisfy this signature. Okay. Go in the function signature, not in the function body. Well, yeah. Types the signature. Okay, sure. Concrete references are the longest. The concrete lifetime that is substituted for A is the part of the scope of X. Oh my god. Whatever, dude. I get it. They live the same. I promise. That's what they're saying. And out of end, Rust features viewed, confused face detected. Voice is noticeably annoyed. I'm annoyed with the documentation. This is like, I feel like I hit this much earlier in the old version. Like, this is super turbo language nerdy. Like, I'm sure this is the most riveting fucking book in the entire world. If you like to think about type systems and look at your navel, all right? I'm sure this is fantastic. But like all of this concrete references to the longest, the concrete lifetime, fucking shut up, dude. Like, put this in an aside. Show me how to use the damn hammer, my dude. Like, I get you trying to explain a complicated thing. You need to condense this into words for people who don't want to study the guts of a language for the rest of their life, right? I want to write software. I'm not annoyed at the feature. This seems like, from what I can pick out of all this shit, there is literally 4 fucking paragraphs here to try to do this, right? fucking get to the point in English. But like what I've picked out here is that you're saying that these things live as long as one another, and this thing lives there too. This scope will go away, but it doesn't matter because these guys are going to be around, is what I've tried to piece together out of here. And if there's something more in there, I'm just going to have to find it out the hard way because fuck the rest of this. Like the feature seems fine. Thing is kind of, you need to understand this to be able to use it correctly. Well, then they should express it clearly. They should shut the fuck up and get to the point. Okay, yeah, all it monads. Fucking bastards. Look at how the lifetime annotates restriction, the longest function by passing in references that have different concrete lifetimes. Okay, so we're going to make a point here. String from this. Long string is long. This goes into a different scope. String from this. Longest, string 1 is string 2 is string. The longest, okay, so these are going to have different lifetimes, is what they're trying to show us. String 1 is valid until the end of the outer scope. Yep. String 2 is valid until the end of the inner scope. Yep. Result references something that is valid until the end of the inner scope. Okay. And because we print it here, it should be okay, right? Borrow checker approves. It will compile and print the longest string. Okay. Now, if you put it outside, it won't, right? Yep, that's what they're about to tell us. Hell yeah, chapter 10. Marco, I tell ya, you've missed out. I have said fuck at computers a lot of times because this chapter sucks ass. Okay. So yeah, they're about to show us exactly what I was just surmising here. Example, it shows the lifetime of the reference in result must be the smaller lifetime, right? Which makes sense. So obviously there's some machinery under the hood, which might have been what they were fumble fucking the football through trying to say. You're essentially putting like a tag on these things that says you need to evaluate the lifetime of this. We already got through traits. Traits are fine. Traits are fucking interfaces with extra flavor. Piece of cake. Call it a goddamn interface. Okay, so must be the smaller lifetime of the two arguments, right? So basically you're making it evaluate. There must be some machinery in the compiler, the analyzer, to say you need to check the lifetimes of these things separately and then compare them, but they're tagged together to like figure out the lesser of the two type of thing, right? That's must be what they're trying to say. Smaller of the lifetime. So we move it outside, leave the assignment inside of here, move the print line that uses the result to the outside scope, will not compile, right? Okay, yes. String 2 does not live long enough. That makes sense. Different mathematical theory behind traits and interfaces, so that's why they're not called interfaces. That would be incorrect. I don't give a shit. There's a different mathematical theory behind different ways to make a hash, and then we all call them hashes. If you want to learn Rust the hard way, what about doing Code Wars in Rust? Isn't Code Wars like the Leet Codey thing? Fuck Leet Code. Leet Code can just go die in a fire. I hate Leet Code. Okay, yeah, so string 2 doesn't live long enough. And I just, yeah, okay. Yada, yada, yada. Get to the point. Way in which you need to specify lifetime parameters depends on what your function is doing. Okay. Sure. For example, if we change the implementation of the longest function to always return the first parameter rather than the longest string slice, we wouldn't need to specify a lifetime on the y parameter. Okay. We specify the lifetime parameter a for the parameter x and the return type, but not for the parameter y because the lifetime of y does not have any relationship with the lifetime of x or the return value. Okay. Code Wars is less about algorithms, more about everyday. I just don't give a shit about CS puzzles at all. I don't care. A math squirt is a math squirt in the category of mathpow.math squirts. Mongoose interface. Yes, I am an interface. Okay, so as long as these two live the same, that's fine. Whatever tagging happens, it's happy. It's fine. Um, a lifetime parameter for the return type needs to match lifetime parameter for one of the parameters. Okay. Reference return does not refer to one of the parameters. It must refer to a value created within this function. However, this would be a dangling reference because the value will go out of scope at the end of the function, right? Consider this attempted implementation that won't compile. References, we make a thing, result is string, goes out of scope. Because the return value lifetime is not related to the lifetime one of the parameters. Okay. Result goes out of scope and gets cleaned up at the end of the longest function. We also trying to return a reference to result from the function. There's no way we can specify lifetime parameters that would change dangling reference, and REST won't let us create a dangling reference in this case. Best fix would be to return an own data type rather than a reference, so that the calling function is responsible. Oh, okay, I see. Egregious. Minus 10 HP. Okay. I kind of get it. I get it enough to go whack my shins on it, I think. Structs to define all hold own types. We can define structs to hold references, but in that case, we would need to add a lifetime annotation on every reference in the struct's definition. Important excerpt that holds a string slice, and they've given it a little lifey time that goes with there. Yeah, I don't care about that at all. Zero interest in doing that thing. Base level Rust question. I have no passion for those things at all. Like, if Rust had a learning mode in what was it called? I'm drawing a blank. Not roadmap, but exorcism. If Rust had a learning mode in exorcism, I would probably do some of the learning mode, maybe all of the learning mode. We'll see. But as soon as it got beyond that, nah, I'm out, man. I'm gonna go make something. And I won't enjoy the learning mode either. I'll be like, nah, I get it. Yeah. It's kind of boring. Okay, so they get the same lifetime tag on them. And then novel is a string from that. First sentence is that. Important excerpt is my first sentence. Struct has a single field part. Yep. Yeah. Main here creates an instance of important excerpt. Even every lifetime reference has a lifetime that you need to supply them for functions or structs that use references. A function in this, yeah, compile without the lifetime annotations. It's historical. In early versions, pre 1.0 of Rust, this code wouldn't have compiled because every reference needed an explicit lifetime. That time, the function signature would have been written like this. Okay. Okay. And so this lives as long as this because these are both references and we need to make sure you live the same length as you do. I did it for JS a year ago. It's okay. Every JS tutorial was treating me as a baby. Yeah. Just wanted to write basic JS functions. Yeah. And that's like it's always hard, right? To find that spot. So like I have a great deal of sympathy for the difficulty of the task. In trying to clearly communicate at a reasonable level what to do and how to get these things into your brains, right? But that's also why people come in and say, well, what do I do to learn? Go make projects, do some tutorials, maybe, if you really want to get some priming the pump in. But then just like start writing stuff. Write crap code. It doesn't matter. You can fix it later. Every reader will have different pre-existing knowledge. Exactly. And like that's why, you know, certain things, like you just have to assume a base level of knowledge in certain things. And if you're trying to cover as many use cases as possible, then like you should be trying to tailor that a little bit more, that experience. If you're trying to cover everything from I've never written code, I don't know what a file is, to like I've written other languages, I'm trying to get up to speed and just get on the wagon, then like you kind of got to be like, okay, hey, like the opposite of the For Dummies books used to do. They used to have little call outs that were like, this is only for people like that already are familiar with the uber nerd language, right? You don't need to read these. This is like extra context. It's not going to do you much good if you don't know what I'm talking about yet. Don't worry, right? You almost need to like either do that or do the inverse and be like, hey, at the start of this chapter, I'm going to teach you what a file is and how to create a new one, how to make a new project. If you know how to do files, skip to chapter 2, my dude. You're good. If you run into issues, I'm always here, right? Okay. So, after writing a lot of Rust code, the Rust team found that Rust programmers were entering the same lifetime annotations over and over. Okay, makes sense. Predictable, followed a few deterministic patterns. Okay, cool. I don't care. First rule is the compiler assigns a lifetime parameter to each parameter that's a reference. In other words, a function with one parameter gets one lifetime parameter. Okay. Function with two parameters gets two separate lifetime parameters and so on. Okay. Second rule is that if there is exactly one input lifetime parameter, that lifetime is assigned to all output lifetime parameters. Okay. The third rule is that if there are multiple input lifetime parameters, but one of them is self or mutable self, because this is a method, the lifetime of self is assigned to all output lifetime. Okay, parameters. This third rule makes methods much nicer to read and write because fewer symbols are necessary. Okay. If there is exactly one input lifetime parameter, it gets assigned to everybody. Each parameter that's a reference gets a lifetime. If there's exactly one input lifetime parameter, so if it's exactly one reference, everybody gets the same lifetime. Multiples, then if one of them is self, then the whole self gets assigned to everybody. Cool. I don't care about pretending to be a compiler. Let's see here. Lifetime names for struct fields always need to be declared after the input keyword when used after the struct's name because those lifetimes are part of the struct's type. Okay. Implement methods on a struct with lifetimes. Method signatures inside the input block. References might be tied to the lifetime of references in the structs fields, right? Because structs, they all get the same lifetime, right? That's what they were saying. So the lifetime of this thing will be the lifetime of this thing. And then there's that. Method name level, whose only parameters are reference to self, whose return value is an I32, which is not a reference to anything. Elision would still work for something like function string and reference to I32. There's only one input. Yeah. Only one input reference, and that will be assigned to the output reference. Makes sense. Which is not a reference to anything. The lifetime parameter declaration after impl and its use after the type name are required, but because of the first elision rule, we're not required to annotate the lifetime of the reference to self. Okay. Third lifetime elision rule applies. Because it's only you and only self, and everybody gets the same. 2 input lifetimes, first lifetime elision rule, and gives both self. Yeah, an announcement their own lifetime. Wait, because the parameter is self. Yeah, return the type gets a lifetime of self. All lifetimes been accounted for. Okay. One special lifetime we need to discuss is static, which denotes that the affected reference can live for the entire duration of the program. All string literals have the static lifetime, which we can annotate as follows. Okay. Text of the string is stored directly in the program's binary, which is always available. Therefore, the lifetime of all string literals is static. Might see suggestions and error messages to use a static lifetime, but before specifying static as the lifetime of your reference, think about whether or not the reference you have actually lives the entire lifetime of your program, and whether you want it to. Most of the time, an error message suggesting the static lifetime results from attempting to create a dangling reference or a mismatch of the available lifetimes. In such cases, the solution is to fix this problem, not to specify the static lifetime. Makes sense, I suppose. Generic type parameters, trait bounds, and lifetimes. Okay. Oh my gosh. Syntax is specifying generic type parameters, trait bounds, and lifetimes all in one function. Longest with an announcement. So we've got an A and a T. Everybody's getting an A. And then except for the T, where the type is display, announcement is the announcement string, and then if length, all that, return the longest one. Okay. Anything that implements the display trait as specified by the where clause. Extra parameter will be printed using that, which is why the display trait bound is necessary. That lifetimes are a type of generic declaration of the lifetime parameter A and the generic type parameter T go in the same list inside the angle brackets after the function name. Lifetimes are a type of generic, then they go in here. Okay. We're done with chapter 10. Oh my gosh. Thank goodness. I'm sure I will end up back there at some point to try to understand something once I whack my shin against it and have some context for it. But that took longer than I really thought it was, but I wanted to make some progress because we've got 11 more sections in total, and we will continue like skimming things that just don't make sense to read. That's kind of like the other, like I wish there was, I talked about it a little bit the other day where I wish there was like an on ramp for I'm familiar with other languages, like hit me with the high levels here sort of thing, and maybe that's Rustlings, I don't know, but like I don't want to skip it because there's important things to know in there. I just wish they got to the point faster and spent less time enjoying their types system quite so much. That kind of is wrestling's, yeah. Yeah, I don't know. Maybe I'll switch. Maybe we'll try it out. Maybe. But yeah. So I need a beverage and to stand up, stretch out, and I'm going to stop and restart the YouTube stream, and we're going to switch to doing some code writing as I continue to melt in the heat. But we're going to get some stuff done today and make progress. Let's go ahead. Actually, check status. Assume code writing is Dart. It is today. There'll be more Dart today. We got to finish up what we were doing in there. We got some bugs we found yesterday to fix up and all kinds of other stuff. But yeah, let me take a break really quick to use the restroom, get that beverage, and then I'll cycle the YouTube stream so that it splits the live VODs for them. And I'll go do that. Cook myself some dinner. Good luck. I hope it's delicious. I hope the rest of your cake is also delicious that's in the fridge. I'll be back. All right. Ate that while watching. Nice. Okay, let's get this squared away. YouTube, I'll be right back. Twitch, we're gonna stay here because like Twitch VODs go away. I don't think anybody watches that many Twitch VODs. It's all right. You like